Okay, there we go. I don't know how bad your audio is. Hi, can I get everyone's attention? Hello, 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 hello. It is past 10 o'clock, which was when I promised I'd start. So, let's start with the first module, lesson, whatever you want to call it, right? So as promised, we'll be doing an introduction to Linux. Okay, so table of contents. I'm not going to read this out. Okay, so let's talk about operating systems for a bit, right? These are the ones that you all should be familiar with, right? Windows, Mac, right? That's usually what comes with your laptop, right? They're proprietary, closed source. So this means that the companies that own them, they don't release source code for it, you can't tinker with it, whatever, right? And you usually have to pay a license for it. When you buy a Mac, you intrinsically buy a license for it. When you get a Windows laptop, usually you pay for a license. If you build your own PC, usually you have to pay for a license, unless you know the methods, right? Today we're going to be talking about Linux, right? Which usually the icon for it is this silly little penguin, right? And to be accurate, it's the new Linux, but we're not going to get into the technicals of that. Okay, so Linux is what's called a Unix-like. Actually, your Macs are also Unix-like. So that's why for the people with MacBooks, I said, oh yeah, if you know Linux install, you can still follow along. Because the commands are basically the same. So Linux is really important because it underpins a lot of the critical systems and infrastructure that we enjoy today, right? Most web servers, and actually most servers in general, run Linux. So most websites that you visit on the back end, they're running Linux. When you play Minecraft, most Minecraft servers are actually running on Linux. Counter-Strike servers run on Linux. I can't speak for Valorant, but yeah, most servers run Linux. Your Internet of Things, right? Your thermostats, your fridges with Wi-Fi enabled, your Ring doorbell, whatever. Those also probably run Linux or a small embedded version of it. Web routers also run Linux. And Android, which I have misspelled in these slides, right, is also built on top of Linux. So that's why when you want to jailbreak an Android phone, it's called rooting, right? And that term actually comes from Unix/Linux, right? Because root is the admin account on Linux. Okay, and this is quite important, right? Understanding Linux is critical if you want to continue exploring cybersecurity or computer science as a whole. And you need to get comfortable with using a terminal or using the console, right? And Linux is a good way to get started with that. Okay, this is also important, right? Because this kind of explains why some of you all have issues with your computers as well. So nowadays, we use what are called 64-bit systems, right? Most of the time when you buy a CPU, it will say, oh, it's a 64-bit or an x64 like CPU, or your Windows installers will say, oh, Windows x64. So this means, as a whole, it can handle numbers up to 2 to the power of 64, which is really big. In the past, we could only do 32-bit, and before that, 16-bit. So last time, you could only install up to like 4 gigs of RAM on a computer, because the computer literally couldn't comprehend more than 4 gigabytes. But we live in the future, and that is not a restriction anymore. So most PCs and laptops use what's called x86 64, right? Which we colloquially know as AMD 64. The exception to this clause in the modern day is the MacBook. So most Macs nowadays run what's called ARM 64 or AR 64. So that's why we are asking you to install a whole bunch of other stuff because they're fundamentally different, right? So you'll learn a lot more about this on Wednesday and Thursday when we cover reverse engineering and binary exploitation. Okay, so yeah, like I said, this is what we commonly work with, AMD 64. This is what's on your Mac. And then on a lot of embedded devices and IoT devices, we use more esoteric, lesser known instruction sets, which you probably don't have to know because I probably won't set a challenge on it. Okay, installation and setup. So this is all the stuff that we were bothering you all with for like the last hour. But nowadays, you do not need to install Linux bare metal. So what we mean by bare metal means like it's on your hard drive as a standalone system. So like me personally, I dual boot, so I've got Windows and Linux installed on my laptop. Our convenience, because I use Linux enough to warrant it. But in the big 2025, you don't need to do that anymore. So for Windows users, we've gotten you to install WSL, which essentially lets you emulate Linux on Windows. And for the Mac users, hopefully you have installed Lima. Okay. Now we can actually start with the content. So this is the shell. So for me, right, on my computer, when I open WSL, this terminal window is the shell. So you can see if I type uname, it tells me this is Linux, right? If I ask who am I, it gives me my username, right? So we call this the terminal or the console, right? And it's a way for you to interface with the Linux operating system. So there are many shells. For example, I'm running ZSH, I think. Am I? Maybe. The answer is no. The answer is no. I'm using Bash right now. So yeah, the most common shell is Bash. You don't actually really need to know that. But for Mac, you all are using ZSH. Now the commands are more or less the same, but there are some minor differences here and there. So hopefully we don't encounter any of those minor differences. Okay, let's start with some really basic commands. So folders or directories, right? Files exist in folders, and in this case, right, you can look at a file by its file path. So it's like when you're in Windows and then you go and get a file, right? Or like, okay, like this folder, right? This is the full path of it. So like right now, I've got C users, June, documents, BlahajCTF, right? That's my full file path for this folder. Now I want to access this in WSL, for example, right? So for the Windows users, you all can follow along. In my case, I will CD. So CD means to change directory. I will CD into the folder that I know exists there. So instead of C colon, so like, oh, where's my thing? So you notice how it starts with C colon, right, for Windows? That is my C drive. To access my C drive on Linux or in WSL, I will CD into MNP, which is short for mount, and then C. So this is my C drive. It's my C drive. Right? You can see these are the standard folders in the C drive. And then from here, I can access users, June, documents, and then BlahajCTF. So this folder and this folder are the same folders, right? We can see that if I make a new file. So like if I make a new text document in here, I can see that that text document is in this folder, right? So I want everyone to try this, right? I want everyone to try and like make a folder and then access it. For my Mac users, this is a bit more straightforward, I believe. Let me try and remember how it works on Mac. Well, my Mac users, let me get a Mac user. Do you have your terminal open? Okay, for Mac users, it's a lot easier because like on Mac, you've got like your documents and your downloads folder and stuff. Once you open the terminal, you can immediately CD into the documents folder. Oh yeah, and for the people that are using Linux already, like in the VM, it should be even easier. right? Okay, everyone managed to make a folder and CD into it? Anyone facing any problems? Okay, so for everyone else, right? Now that we have made a folder and we have seeded into it, right? Here's the first command that you guys should try and input, pwd. Type pwd and then hit enter. So typing pwd should display the full path. It should display the full path of the folder that you're currently in. So far, so correct. Okay, that was 3 letters and the enter key, so it shouldn't have taken too long. Okay, the next thing that I want you all to try is to make a directory inside the folder. So to do it, you do mkdir, which stands for make directory, and then the name of the directory you want. So I'll make a directory called like dir1. And then you can see it's made a new folder called dir1 for me. So I want everyone to try this as well. Yeah, if you're lost or confused, raise your hand and one of my kind TAs will come and help. No. Now it's small. Okay, for everyone that has just tried typing this command, right, you should not be seeing any feedback. So you notice how after I typed it and I hit enter, it just sends me straight back to the shell. So if I want to enter this directory that I've just made, right, I will run the command cd dir1. And this takes me into the folder that was just created. Ten? Okay, then if I want to exit this folder and I want to go back to the previous folder I was in, right, I will do cd ... So ... means to go to the parent folder or the folder that contains the one that I just made. Okay, so after this one, right, the next command that I want you all to try is cd ... the little squiggly fella, right? When you hit that, you should notice that your thing now just shows a tilde, right? Or maybe it doesn't, it depends on what shell you're running, right? This is a shortcut to access your home directory. So on like a default Linux installation, everyone has a home directory and you can access it trivially with tilde. Okay, and finally to go back to the folder that we were in just now, you can do cd dash. And it'll print out the path of the folder that I'm returning to, and it'll bring me back to it. So this is some basic navigation of folders in the terminal, right? Okay, anyone having any problems with these commands? Should be straightforward enough. Okay, next command that you all will learn, ls. So ls is short for list, and it will list out all the files in the directory. So in this case, just now I made a text document inside, right? So that's what it shows here. And everyone should have made the directory as well. So when you hit ls, it should at minimum show that directory that you just made, right? So if I add more files to this folder, I will see more files when I type ls. Okay, so that's ls on its own, right? But ls doesn't actually show everything that's in the folder. If you do ls space -a, right? So this is called a flag. Whenever we do a dash and then followed by a letter, or like dash followed by a word, something like that, that's what we call a command flag. So in this case, the flag is A, right? -A, which stands for all. So notice how after I add the -a, I've now got two extra things that have showed up, which is dot and dot dot. So these were initially hidden when you perform ls, but now you can see it when you do ls-a. So this is a quirk of Linux, right? If you have a file that starts with a dot, when you do ls, it won't show up. But when you do ls-a, it will show up. So don't think about it as some archaic thing, but like if you're looking at a folder and you're like, oh man, where's this file? Why can't I see this file? Consider doing ls-a. Okay, the next flag that you can try is ls-l. So ls-l, L stands for long, and it will show more details about the files that are inside the folder. So you can see here, it's got like a bunch of letters and stuff. It shows me who owns the file, and it shows me the size of the file. It shows me when the file was created, right? So ls-l gives me more information. Okay, now any guesses on how to display long information and all the files at the same time? Anyone? Any takers? You can say it out loud. Well, what? -l. But I want to see all the files as well at the same time. Because you see, -a shows me all the files, right? And -l shows me the full information. So how do I do both at the same time? Okay, so one way you can do it is to do -l-a or -a-l, right? So this is chaining the flags together. So now notice when I do ls-l-a, I can see the full information of dot and dot dot also. A shorter way to do this is just to do -la. So this chains the flags together, right? So you'll be typing this a lot, probably ls-la, hopefully. Okay, now some more basic commands, right? If I want to make a blank file, with nothing in it, you do touch, you type touch, like touching something, touch space, and then the name of the file that you want. So like, for example, if I do touch file1, now when I do ls-la, you can see I now have a blank file called file1. That's how you make a file. Make a blank file. So again, if I go back to my Windows directory, you can see all of these files just being made. Okay, another thing you can try. So let's say you have a file that has text or like content inside, and you want to just print the content in the console and see what's inside. You can do cat, like cat, like meow, right? So, for example, my test.txt file has a bunch of text inside, so when I do cat test.txt, it displays the contents of the file onto my console. Obviously, if you do this on the file that you created just now with touch, you won't see anything because the file is blank. Okay. Next, so now that we've done touch and we've done cat, let's do some copying and moving. So CP, short for copy, right? The way that it works is you do CP with the path to the file you want to copy, and then the path to where you want to copy it to. So for example, if I do CP file1, file2, I have now created a file2 which should have the same contents as file1. Like I showed just now, I have test.txt, which has a bunch of text inside. So if I do cp test.txt and then new file.txt, now when I print the contents of new file, it has the contents of test.txt. Okay, everyone clear on how to copy files? Anyone have any problems so far? Yes, no, yes, no. All good? All good? Okay, next one, right? So CP is the copy files, but what if you want to move them? So you just want to move it from place A to place B without having to copy it all together, right? You use MV. MV is short for move, right? So, for example, if I want to rename a file, so just now I have test.txt, right? If I move it into a new file name, like test2.txt, you can see test.txt is gone now, and it has been renamed to test2.txt because I moved it from the name test.txt into the name test2.txt. Also, if I want to move it to a different directory, I can. So like I can do move test2.txt. And just now we made the dir or whatever you wanted to call your directory. So I have dir1 here. If I move, let me just call this one test also. So for example, my command here is move test2.txt, dir1 test.txt. What this does, if I enter dir1 now, and then I list out my files there, tada, test.txt is now in there. Because I've moved this test2.txt, I moved it into the dir1 folder, and now it's there. Okay, let me cd out to cd out, like I said just now, cd . Okay, now lastly, if I want to delete a file, right, the delete command is rm, remove. So let's say I want to get rid of test2, I just do rm test2. And now it's gone. Whoosh. Right. So yeah, these are the basic commands that you need to make files, print files, copy files, move files, remove files. So it's a lot less intuitive than just clicking on things and right-clicking and deleting and whatever, right? But that's what happens when you don't have a GUI graphical interface to work with, right? You got to type things out. So I will send these slides to the chat after today, so y'all can review the commands if you want. There aren't a lot. Okay, next. Now that we understand how files work, right? Files are just files, but in Linux, everything is a file. So something that we need to concern ourselves with are what are called streams. So when you print stuff to the console, it's using what's called the standard output stream. When you type things into the console, it's using what's called the standard input stream. And when the program errors out, it's using the standard error stream. So you can think of this as pipes. It's a bit unintuitive, but it will make sense really quickly. So first thing I want you all to try is to run this command. So echo, and then some text. So like it can be hello world, it can be like lol, and then caret and then a file name. So like I'm just gonna do like name.txt. So let's break down this command, right? What echo does in the console is actually just repeat what you type after it. So if you just type echo lol without doing anything, the console will say lol. If I do like echo text, it will echo back text. It's a very literal command. However, if I add the caret and then I add a file name afterwards, what it is doing is redirecting the output. So instead of it outputting to my console, it will redirect the output into the file. So just now we did echo lol into name.txt. Now if I use cat to view the contents of name.txt, text lol is there. If I do echo new text into name.txt, now when I cat, it says new text. So this is a quick and dirty way to toss text into a file, right? But what if I don't want to overwrite it? So like every time I do echo and then the right caret, right, it just sort of wipes the file and puts whatever I want in there. So that's when you use two carets. So like if I do echo new text to, and then write name.txt. Now if I cat name.txt, you notice it has added my new text to as a new line. So if you want a very, very slow way of writing a document in the console, you can do this. You can type it line by line, and you echo every single line into the file that you want to write. Obviously, this is not the most efficient way to do it, but I mean, y'all are supposed to learn how this works. So, okay, another set of commands, right? The head and the tail. So this is a very silly command. Well, not actually that silly. If you do head on a file that has text inside, you see in this case, it just prints out the two lines that are inside. So it's like, oh, what's the difference between cat and head, right? The difference comes in when the file is really big. So let me think of a really big file that I have on my computer. Do I have a really big file anywhere? This looks like a big file. Okay. You don't have to follow along for this like these commands. I'm just going to show it to you all. Cat. Do I not? Is it not there? Oh man, that file was a lot shorter than I thought. Let me pick something else that's longer. Okay. Underscore. Okay, this is a big file that doesn't display properly in the console, right? So like this is actually a zip archive, but I have intentionally catted it to the command line, and you can see it just comes out as a bunch of garbage, right? Cat, let me do that again. Oh. Actually, I should have done that. That broke my thing. Whoops. Just want to show how head works. Should have prepared a file. Okay, if you run head instead of cat, it will display only the first few lines of the thing, so it doesn't completely flood your console. So this time around, I didn't break my console because head only displays the first few bytes of the file. Similarly, if you do tail, tail will display the last few bytes of a file. So notice how it didn't flood my console this time. So when you are looking at really big files, you can use head and tail to look at the start and the end. Okay, now this is, okay. Here's another set of commands that are kind of cool, right? So notice the existence of the line. So this line, this single line, is a pipe. So remember, ls-la displays all the contents of a directory. So this is just some directory I have, right? It has all of these files inside, right? Now, if I do ls-la, then I make a pipe, and then I pipe it into this command called nl. See, now there's a bunch of numbers at the start. What nl does is it actually shows you the number of lines in a file, right? So like if I do nl readme.md, for example, it will show me, yeah, there are 2 lines inside this file. However, if I do ls-la, and then I pipe it into nl, it will take the contents of ls-la and then treat it as a file, and then toss it into nl. So now it shows me the number of lines when I run ls-la, right? Okay, let me go back to the folder that I'm supposed to be using. Another thing you can do. Okay, the second command is kind of nothing burger. The third one, t. So if I do ls-la, then t something.txt. So notice it prints out the result of ls-la. But then now, if I do ls, something.txt exists. And if I cat something.txt, the contents of something.txt is the output of ls-la. So this command is a way to get the output of the first command and then pipe it into this file while printing out the output of the command for you. So this might be a bit confusing. It might be a bit confusing at first blush. You won't be doing this a lot, thankfully, but you still need to know how it works. So how is this relevant, right? Sometimes you have programs that you want to push input into, or sometimes you have a program that outputs something, and you want to take that output and put it into another program straight away, right? It'd be a bit funny if you had to run the program 1, then you copy the output of the program, and you run program 2, and then you paste it in, right? Using pipes and redirection is a way to very directly do it in Linux. Okay, this one is for information. This is for information, and you will eventually have to do it. Lucas, where's Lucas? Lucas, would it be doing this later? Would it be catting into anything? No. Okay. You will be seeing more of this probably tomorrow when we start on cryptography, right? So during CTFs and during Blahaj as well, so on Saturday, you guys will encounter this. There will be a lot of services that you will have to interact with in the console that are remote, which means they exist on a different server, right? The way that you connect to a remote server very easily in Linux is using this program called netcat, or NC for short. So we will run through how this command works in a future juncture. I will not have to go through it now. Another thing to go through is file permissions. So I know I said I was going to gloss over it, but I lied. When we do ls-la, there's like all of this stuff at the start, right? This actually means something. So files are readable. R means readable. Writable, W. and sometimes executable, which is X. So notice how all of these files that I made read, write, and executable off the back. But that isn't usually the case. And also, they can be directories. Directories are D, right? So, like for example, let me see if I can get different verbs here. So, how do I CD bin or something? Okay, see, for example, in this other folder, the bin folder, right, some of these files are not writable. They're missing the W, which means you cannot write to them. They are read only or executable, well, they're read and executable only. So that means you can't modify their contents. But there are some files that are links that are writable. So, and notice how all of this is root. It says root instead of June, right? Because these files are owned by the root user rather than my user. So, again, this is mostly for information, but it's because sometimes you'll encounter moments where, like, let's say you have a file and you can't run it. Right? Let me see, do I have any files here? Do I have any files I can run out of Python? Okay, and this binary of Python crashes, but I can run it, right? Like when you encounter a file that's runnable, you can do / the file name, and then it will run. But sometimes it's not runnable immediately, so you have to change the permissions. So for example, this command chmod plus X in the file name, that makes the file executable. So, like I said, you can see the details of the file permissions when you do ls-l. So this will be relevant. Lucas, is this relevant later? Do they have to do a UID? No. This will be relevant on Thursday. Okay, that's it for the Linux introduction. Those are all the basic commands that you more or less need to know to navigate your way through the BlahajCTF, and also for the rest of the sessions for this week. So, if you got lost, or if anyone has any questions right now, the floor is open. Anyone has any questions? Will you get the slides? I will send the slides into the Discord tonight. Does anyone have any other questions?
Sorry, can you clarify what particular
key? Okay. So basically, if I do ls-la, let me try that. Okay, so notice if I do it like this, right, it doesn't work. Because what's going on is it runs this as command 1, and then it types the output into command 2. But this file is not a command, right? When I run T creates a... So what would work here, right, is if I did the caret, right? I do the caret and then I do lol.txt. So, whoa, whoops. My thing is tweaking. Okay, ls-la into lol.txt. So this would type the output of ls-la into lol.txt, right? So if I cat lol.txt, I will see the output of ls-la. However, notice when I did that, notice when I ran this command with the redirection, I don't see the output of ls-la in the console. So like I'm blind to what's actually being written into lol.txt. However, if I type it into T instead, so the type and then T is like doing the right caret, except when I run it, it will show me the output of the first command as well. And it will pipe the output of the command into the next step. Yeah. So
it's like one big function.
Yeah, you can think of it as one big function. Okay, anyone else have any questions? I will answer questions for the next 5 minutes before I hand off to Lucas. Yes? Yes? Right. You got it. Not a big problem. Okay, anyone else have any questions? Yes. Oh yeah, I glossed over this one. Since we have a bit of time, I'll just show. If I do this, so this command is kind of cool because what it does is it takes the output of ls-la and pipes it into this thing called grep. So grep is a program that's very useful for this thing called regex or regular expressions. Right? You do not need to know the syntax for grep right now, but what this command does is it isolates any files in ls-la which end with the extension .txt. So like, for example, if I only want to look at files that end with .py, whoops, my thing is not having a fun time today. Maybe you should have done that this time. Bro, stop. Oh my god. See, if I run grep and then I change the .txt to .py, it will now only show me files that end with .py. Or if I change this to md, it will only show me files that end with md. Right. See, if I just have a dot, then it just gives me anything that ends with a character, which is everything. You can see what's being highlighted. So this is, again, like just sort of a clump of information that you can go and research more on your own. Right? grep is very powerful, it's very useful, but for the time being, I'm not going to elaborate. It's just part of the regular expression. You don't have to think about it. I will elaborate no further on grep for the time being. You can Google these things yourselves. Please don't ask ChatGPT. Okay, anything else? Any other questions? Anyone else got questions? Across the board? No? Okay, since I'm assuming that there are no more questions, I am going to hand over the time to Lucas, and he will get you all started with web exploitation.
Before we begin, let's have a 10-minute toilet break, because I need to use the toilet.
Actually, it'll be left.
It's supposed to be 12 to 1. It's supposed to be 12.
12 to 1.
Not that.
Okay.
So let's come back at 11.
Okay, lunch is 12 to 1, I lied. It's not 11 to 12, my bad. 11's kind of early to eat lunch anyways. Toilet. I think you go out and turn left. I think so. If it's not left, turn right.
Okay. You start at 11.
Yeah.
How do I turn off?
It's on.
But if I want to turn it off. Yes. Your charger is.
Oh, the stream isn't reflecting your.
Oh. That's strange. What is that?
This is certified hyperland movement.
Certified hard.
Okay, wait.
Fresh.
Let me just. Oh,
Now it's then.
hey, there we go.
But I don't know what this thing is. I think it's
Whatever. It's because it's not full resolution.
yeah, I think so. Let me try to fix it.
No, you don't have to. It's a feature, not a bug.
Feature. Oh.
I mean, as long as they can see the slides, it's fine.
Oh, okay. I see it. This is my first time actually trying to screen share on Linux.
I don't know, from experience, it just works out. Okay, well, I'm gonna mute the stream while we're doing this. Okay, you can start whenever you want.
I'll start at 11. Or should I just start?
No, you said 11.
Yeah, then just start.
Okay, we'll start the lesson in 3 minutes. 3 minutes. 11 o'clock sharp.
Hi guys, let's start on our web exploitation workshop. So today will be quite. Give me a moment. Yeah, I don't know why there's like stuff at the side, but yeah, just ignore the stuff. So today we'll be going through like quite simple stuff. So since you guys already know Linux, we start with command injection, and then we'll go a little bit into SQL injection, and then we have lunch. And then when we come back, we'll do more on more on SQL injection, and then XS and SSTI. If you guys know what these are. If you don't know, I'm here to teach you. So yeah. So here are some prerequisites. So first up, I want to check if you can access this, because we'll be using this IP for our training challenges. So just go to this IP and see if you can see your login screen. It should look something like this. It should look like this. So IP is 174.138.18.127. Port 5000. It should look like this. Yeah. If anyone has any issues trying to connect, you let me know. Oh, yeah. If you get like some protocol error, right? It's HTTP, not HTTPS. So change the scheme to HTTP. Then try it. Nothing. This will be one of the challenges that we're going through. So you can just, if you can see username password, right? Then that's good. Yeah. For those who can access already, right? I'll also be using Burp Suite. If you know what Burp Suite is, it's not compulsory. Like you don't need it to solve most of the challenges, but it'll be good to have. It's like more convenient. Yeah, community edition. I have to just try. Okay, if you don't have Burp Suite, it's okay. You can, if you want, you can set up over lunch or something. You won't be using it for now. Then the rest of the challenges, you can find it in this tiny URL. So it's in the Google Drive and is over here. Yeah, so you can just go in whenever you have time. We'll be going through the first 4 challenges, and then the next 3 is just for you. The next 4 is for you to try in your free time. Yeah. Okay. Anyone has any issues? If not, I will. Oh, okay. Okay, I'm gonna start. So, our first one is very easy. It's just command injection, and everyone knows Linux here, so it should be quite easy. So, let's say you have this command, right? Let's say we have some web server that's just taking our input, putting it into this command, echo, and then your input, and then pipe into base64. Anyone can tell me what this does? Do you learn base64? I don't think so, but you don't even know what base64 does. Just tell me what this echo command does. Anyone? Echoes the input, right? Yeah. So we are echoing the input, we are piping it into base64. So let's just try something here. Let's say we do echo ASDF to base64. Okay, echo ASDF base64. Payload is too small. This is the good size. So it just echoes this into base64, and then it will pipe out the base64 representation of ASDF, right? So if you remove base64, it doesn't matter, like it's just ASDF. Yeah. So that's the intended usage of this, right? We don't want as the developer of web, so you don't want people to like inject random things into here to run like their own commands. We want them to input strings, right? But this implementation can be vulnerable. Let's say you do this. If we do a semicolon, right? The shell is going to interpret the semicolon as the end of the echo command, and then if we just cover this, right? So echo nothing, and then it's like type base64. This is invalid syntax, right? Sorry. Give me a moment.
How is it working there? This stream is okay. I can put into Windows. Okay, just give me a moment. I'll put into Windows. Okay, I'm gonna put into Windows. Just give me a moment. Your friends in the YouTube stream can't see the stream for some reason. It just frozen. We're using Windows now. Yeah. How to get away from Windows? It's not possible.
I'm safe.
Okay, we are back, guys. We are so back. Okay, so back to this, right? So this command is going to be invalid. It's going to show an error now, because like you're trying to type, you didn't run anything before this. This is not a valid like bash syntax, right? But what if we did something else? What if we did something like this? Right, so I don't think you've learned backticks yet, so I'm going to teach you backticks. So what this does is it's going to run this subcommand cat etc password first before it runs the echo command outside. So it will run this, put the output of this into the echo command, and then type it to base64. And we can try it out here. Yes. Right, you see, this is not my cat etc password shouldn't be this long. So we are actually running something here. And if I just remove the base64, you can see it's catting my file, my etc password file. Oh, very small. Sorry. It's better. So yeah, it's catting something up. We can do other stuff, so we can cat like ls-le. Right, and then it's going to run something else. So this is our first vulnerability. We can run commands inside other commands, and because this backtick is being interpreted not as content. This is supposed to be content, but it's being interpreted as syntax now. So that is the vulnerability. And actually we find that a lot of, it's later on. But we have other kinds of syntaxes we can do. So we can use parentheses. We also run the subcommand inside. And then we can use semicolon like just now, right? And then we run the command afterwards. We have other stuff also like type. This one will run the command in the background. These two will run the commands sequentially. But you can see that there are a lot of different symbols that an attacker can use to actually escape the content part of a command and inject things into the syntax part of a command. So a lot of our injection vulnerabilities are actually based on this. We are interpreting content as code.
Can you like do a recap of the first few slides? Just like a quick recap.
Okay, someone in the YouTube stream wants me to recap everything, so I'm gonna recap everything. Okay, just a quick recap. So our injection here, we put content into the command. I mean, the web server expects us to put content in the command, but we can put code in the command instead, right? And then we can run our own commands. So this is dangerous. I mean, you can run anything you want on the server, which is basically compromising the server. Right? And today, all the vulnerabilities that we're going to look at, they are all injection vulnerabilities. So this just keep in mind this context. We are interpreting content as code, right? So yeah, that's all for command. Let's look at SQL injection. For those who don't know what SQL is, SQL stands for Structured Query Language. So we use it to query data from databases. And it's not important what the dialects are at this point, but we will be using SQLite today for our challenges. But there are a few others like Postgres, MySQL, Oracle. Yeah, but we're using SQL. So the differences in these dialects is very minor. Most of the stuff you can do on SQLite or MySQL, you can do on Postgres, you can do on Oracle. But there will be some differences which I'll go through later. Okay, so this is what a query looks like, SQL query. So we have an action that we want to do. This action, we want to select. So when we select something, we select data, right? So where we want to select data from, we select from a table. So a table contains, it is just like your Excel, Google Sheets, contains columns, contains rows. Each column, we can select, we can choose which columns we want to select from, or we can select from all columns using asterisk. And then we have a condition where a certain column is equal to a certain value. So in this case, what we're going to do is we're going to select the columns username and password from the users table, where the username column is equal to user1. So this is quite a common query that you want to do. Let's say you want to log in to a web page, right? You want to select, so you want to log in as user1. You select user1's password, and then you compare with the password that the user supplied, right? And then see if it's the same password. So here are some of the actions that we can do. Besides select, we can do insert, update, delete. It's not very relevant for today, but so as the name suggests, insert is creating a new row in the table. So over here you can see the columns that you want to set, the values that you want to set. Yeah. And then update is changing a row, changing the data that is stored in the row. So in update and delete, we can use the conditions. We can't use it in insert because it doesn't make sense. You can't specify a condition on an insert, something that doesn't exist yet. But we can use it in update and delete. So in update, we can choose a certain row where, let's say, username equals to user1, and then we want to change the person's username and password. So this is how you do it. And then you can also delete a row from the table. Yeah. So it's important to note that later on, when we are going to do our SQL injection, right? You cannot put you usually cannot put let's say you want to put a delete query inside a select query. You can't usually do that. Usually it's like one query, another query, but you can do select queries inside another select query. So that's the only caveat to this. But anyway, our vulnerability won't allow us to, if we are able to execute arbitrary SQL, right, or SQL injection, we cannot delete stuff from the table, but we can still delete stuff. Yeah. It depends what adapter, SQL adapter you're using, but most of them don't allow you to do this kind of batch queries. Oh yeah, okay, so I explained this, right? Conditions. These are some of the keywords. So if you want to do multiple conditions, you can use and. So you just select by 2 columns. Or you can use or. Which will, all is quite self-explanatory. So you can see over here, you can also use values instead of columns. So we've always been using columns for our conditions, but you can also use primitives like strings, numbers to match instead. It doesn't have to be a column on the left-hand side, which will be important for our SQL injection data. Okay, so we have the same scenario here. We have 2 inputs now. We can input into username and input into password, right? This count one is just a function where it just count the number of rows that is returned by the query. It's not important. So we can input into here, we can input into here, right? This is a valid usage of expected usage of this query. So we want to log in as admin, and then we want to log in with the password ASDF. So if the password isn't ASDF, then this won't allow us to log in because this condition here is filtering by n, so it will return 0 rows, right? So, but the injection here is like just now, right? What if you put a code in here? If you put a code, it becomes code, right? Our content is being interpreted as code. So So you can see here. We can just escape the string, escape this string, and then we put our own condition, or ASTF, or even or 1 equals 1, right? Either of these. So now the query becomes just our password field is now just being ignored because this condition 1 equals 1 will always return true, and then the password comparison just doesn't matter anymore. This thing over here, this is a like comment, is to comment out the rest of the query, because if we don't comment it out, there will be an invalid syntax here. So we just comment out the rest. Yeah. So okay, let's just do the demo now. One second. Yeah. Okay, so this is the first demo challenge we're going to do. So, actually, let's look at the source code first. So, if you go to the Google Drive, the Google Drive contains the source code for all these, for all the challenges. So, the first one we'll be doing is on port 5000. So, you can see over here, 5000, then just go inside. You can download the list. Yeah, sure. Sorry? I'll send in Discord. Okay, I sent the link to the Discord training announcements channel, so you can go there and refer to it. Okay, yeah. Okay, let me download this first. I don't have this. Okay, now let's look at the source code. So, okay, actually, I forgot to change the admin password. So actually, if you want to log in, right, you can actually just look at the admin password. But let's do this. Let's not do this for now. This is the shape of our table. You can see that there's a second table. They will be looking at that later. But so there's an admin user, and then it has a certain password lah. Let's pretend we don't know the password. But I forgot to change it on remote, so it's actually the same password. But so you can see over here, this is the login page. Here, this is the query we are executing. So it's the same as just now. We are putting the username in the username field and the password field. So let's try just with just like this. Okay, we can see our query here. Let me zoom in. We can see our query is being executed like this. So when username goes to admin, password is and this is wrong lah. Invalid admin username password. Now let's try putting a code, single code inside the password field. Like this. internal server error. Okay. So if we look at the query that's being computed, it's erroring out because this is the query that's being executed. Right, this is being executed, and then you can see that there's an extra code at the end. So this is embedded SQL syntax. So this is how we, even if we didn't have the source code, this is how we can usually identify that there's a SQL injection. When we try to put this or like maybe double quotes, and then it suddenly errors out, right? It shouldn't be erroring out, it should just be, I mean, if there wasn't an injection vector, it should just take this as our password. But since the errors out, we know that we can probably inject some SQL now. We can do something, right? So let's just try it with this, or 1 equals 1. Okay, and that's all the challenge. Yeah, so that's the query again. So now this is the thing that we discussed earlier here. Yeah, this is exactly what's happening. So yeah, honestly, yeah, that's all. Anyone lost right now, or is it okay? If anyone's lost, you can raise your hand and ask questions. Okay, if not, let's move on. So this is quite limited lah. Like in the sense like we can't really, we can log in, let's say we can log in as admin, but what if we want to retrieve something else from the database, right? Because we can execute arbitrary SQL, we can do much better than just passing a certain query. Like as in getting a query to return true itself, or the condition to return true itself false. We can do much better. We can try to retrieve data from the table instead. So there's this new keyword that I want to introduce. It's called union. So I don't know if you learned this in like secondary school or like JC, right? But like union, you're joining two sets together, right? This is the background of this, like the etymology of this keyword. So you join two sets together, and then you return the full set as the new set. So the combination of the two sets, right? So likewise in SQL, we can use union. We can join two sets of select queries, the results of the select queries together. So let's say in this example here, union select name one from special users. Let's say you have a table called special users. So this will join the output of username password from users with the output of name one from special users. And then it will just return it as if they were both from the same table. So with our injection vector, we can inject this union select keyword in. Then we can select data from any table in the database, right? As long as they have the same number of columns, because you need to have the same number of columns in order to join the results of the two queries together. So that's the only restriction we have on this union select. Other than that, we can select data from any table in the database, and that's quite powerful actually. So here we have another query. So let's say you have a post table, and then we want to select, the web server wants to select title and description, where username equals to something. As usual, we can just escape the code here. So union select username password from users. We will join these to a post, and then now our web server is going to return all the usernames of users as the post titles, and then all the passwords of users as the post description. So give a demo. Okay, I will go through this one. So let's say we don't know the number of columns, because we need to have the same number of columns, right? And then we try something like this. So select now, it's just going to select one column. It's, all these are special, okay. I forgot to mention earlier that you don't need to put columns in the select, when you're selecting columns, you don't need to put columns, you can put values also, just like in conditions. So now is a value. So you try to select one column from users and then join it to post. But you don't know how many columns post is trying to select because we are using asterisk now, right? So it could be any number of columns. So how do we determine how many columns to select, right? It's quite easy. We just add another noun, add another noun, and then suddenly this one doesn't error out. So if this one doesn't error out, means that there are 3 columns, right? And it's honestly quite easy to do this. You don't need to like do script and anything. Just keep adding columns in your injection. Okay. Before I go into that, I'm going to do the second challenge first. So, if you wanna follow along, you can download the zip as well. Okay, so we have the exact same scenario here. Now we have okay, it's not exactly the same, but let me see. So we have a post table which stores 3 columns: ID, username, and description. And then we have some post line. This is not important. And then now we have this other table here that we want to select from, right? Right now we know the table name, we know the column that we want to select from. But okay, I'll go through later what we can do if we don't know these. But right now we know these. So we just want to select flag for Blahaj from the Blahaj flag table. And then this is the flag we want to get, right? So let's go to the challenge. And let's try to search for users post. Okay, so we'll, based on the query that's being executed, let me show you the query. Sorry. Let me show you the query. The query is over here, right? We want to select all columns from post where username equals to, in this case, admin. So sorry, we will be selecting behind. We'll be selecting just this post now, and then return the description and the title. Here. Oh, sorry, the username. The username and the description. Right, okay. Same thing, let's try to put a code again. And as you can see, it will, it doesn't error out, but it doesn't error out completely, but it does kind of error out, right? So we know that there's some SQL injection going on here. So now let's try the payload that we saw earlier. Union select. And our flag, the column that we want to select is flag for Blahaj, right? So flag is for from this is going to error out because just now we said that it has to be the same number of columns. And if you look at the query, you don't exactly know. Sorry, my machine is quite laggy. these windows. Okay. Okay, so this query, we don't know how many columns, very small. We don't know how many columns we are trying to select at this point. But of course, we know because we can see the.
I can't see it from the back.
Wait, can everyone see this? Is this big enough? The guys are like lazy. Cannot see. Okay, is this okay? Can okay. Yeah, okay. So like I was saying, right, we let's assume we don't know how many columns this is translated. Let's just add running that or something. Union select. Okay, so let's say you have this, right? And then we don't know how many columns, so we add a noun. Now from large error again, add another noun. Now from large, and it's returning none, but okay, it didn't error. So now we know we have 3 columns, right? And then why is it returning none? We don't need to know, but actually it's because if you look in the source code, the first column so when you do asterisk, the first column that is being selected is ID. So it's ID, then username, description. It's just in the order that it was declared in the, or like in the order that it was created when it was in the order that it was declared when the table was created. Yeah. So in our union select, the flag for BlahajCTF is inside the ID column right now. So you can see that over here there's no ID column that's being returned. So all we need to do is to move this to the second one or the third one. And then this flag for BlahajCTF will go into username or description. So okay, let's do that. No. And did I not update the flag? Okay, okay, this is the flag, I guess. But yeah, so we have the flag. Yeah, and that's union select. Okay, now we have another thing we want to consider. What if we don't have access to this this init.sql? So we don't know the name that we want to select. We don't know the column we want to select, but we know we want to select something, right? We can actually introspect the database. So database introspection. And I will show you how to do it for SQLite and then MySQL, because MySQL syntax is actually the same as for not Oracle, but for Postgres it's the same. I think for MS SQL is the same as well. So it's useful to know these two. For SQLite it's very simple. There's just a table called SQLite master, and it contains the names of all the tables that are created, as well as the query that was used to create them. And these are stored in name and SQL columns, respectively. For MySQL, it's a bit more complicated. So there's this table called information schema.tables, which contains the information of all the tables. And each column in a table is a row in this information schema of tables. So first we want to find a table name, right? So you can select table name from information schema.tables. And then we want to find all the columns that pertain to this table. So we select column name from information schema.tables where table name equals to, let's say, users, or the table that you want to target. Yeah, for SQLite, all the columns, you can already see them in the create query that's used to create the table. So you don't need to do this extra step. And yeah, okay, let's try that. So let's pretend that we don't know BlahajFlag, we don't know flag from Blahaj. So we have to get SQLite master. So we'll be selecting from okay, the query is a bit cut off, but I'll just show you. So this is the query executing. Select now name SQL from SQLite master, and then this will append all the rows in SQLite master to the result of our query. So we can see there are 3 tables here. We can ignore this one. The only 2 important ones are this one and this one. So this is the table we are selecting from initially, and then we can see this table. We want to select from this table. So now that's all. Now it's equivalent to having the init.sql already. So we can see table Blahaj flag, flag for Blahaj is a column. Yeah, that's all. I don't have a MySQL instance set up, but I can do it if you want actually. Let me do this. Can you still see this font size? Is it too small? The guy at the back. Is it okay? Is this okay? Is this okay? Is this okay? Yeah. That. Okay. You can. Okay. Right now I'm just gonna execute the commands directly because I don't have a challenge that's using MySQL. So I'll just show you the result of queries being executed in the database directly. Okay, I kind of forgot how to use MySQL. Okay, sorry for the delay. Just going to create a table now. Okay, we just have one table. That's enough to demonstrate. So now let's say we can, I'm going to skip the union select. I'm just going to do the selecting from the information schema table directly. So select table. And you can see there are actually a lot of tables in this one as compared to SQL Line. Right, but all these are all not important. The only one that's important for us is all the way at the end, because this is the new table that was created. So all user-defined tables will be at the end. Actually, no. Yes, it is. So it's ordered by time of creation. So all the user-defined tables will be at the end of the query. So we can, okay, I'll just get that. So okay, let's say we know there's a users table already now. So now we want to select all the columns, or we want to show all the columns from this table, right? So where table name. My bad. It's not column name. Can you see this font size? Just kidding. It is not column name, it is information schema.columns. My bad. Select. Okay. So sorry, I will amend this in the slides. It's not information schema.table. So after you find the table name from information schema.tables, you need to find the column name from information schema.columns. And then it's still column, to get the name of the column in the users table, it's still column name from information schema.columns. So these are also system generated columns. These are also system generated. These are the columns you're interested in. So yeah, that's how you do it for MySQL. I think let me see. It's lunchtime. It's lunchtime. Okay, dude, what's the plan for lunch? Is lunch yet? Thank you for bearing me so far. We'll be having lunch from 12 to 1, and then we'll come back home. How are we setting up the CSIT?
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunted down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunted down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunted down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunted down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading. Hunt it down fast. Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core.
Hunt it down fast.
Be rewarded with up to $30,000. You in? Every keystroke counts. Every second matters. It's a race to the core. Systems down. Enemy detected. A silent cyber parasite is spreading.
Hunt it down fast.
Be rewarded with up to $30,000.
Okay, chat. It's 1 p.m. It's 1300 hours. You know what? You know what that means? It's time to get back to learning.
Okay, before I carry on with the rest of the stuff, I want to do a quick recap of the stuff that we've learned so far. So, I'm going to, no, I'm not going to, you are going to solve the challenges for me. You're going to tell me what to type in. So, actually, no, I'll get someone to come up and do it for me and demo to everyone. Let's start with the login. Any volunteers? Anyone wants to solve challenges on screen? If not, I'll pick. Anybody?
Feel free to arrow.
Actually, give me a moment. Okay, it's up. The challenge is up. Okay, any else try? Oh, you can't see that, sorry. Okay, I'm going to arrow.
Okay.
Okay. You can teach everyone how to do SQL injection. Either just
For SQL injection, assuming that it's SQL line, it's running on SQL line. I'll check this SaaS website first. So I'll do like random. See if it works. See if I can guess correctly. And your Wi-Fi is really bad.
My Wi-Fi is really bad.
Okay, so I'm guessing it shows an error from past experiences. So oh,
I'm going to make my Wi-Fi good. Give me a moment. Too many people on this one.
was it like that?
It's like quite like sometimes
Yeah. Sorry, technical difficulties.
Routers are plugging your laptop.
Oh yeah.
Does it have with the Wi-Fi?
This is quite sad. It's quite sad. Let me try it. It's not. It may not be even be the Wi-Fi.
Your server.
My server. Ah, wait.
Oh, you have slides there, that's true.
No, but I want you to do it. For real.
Is it the same one as just now?
It's the login. You want to take a seat first?
Alright, sure.
Yeah, I'm going to upgrade my server because my server is too slow. So give me 5 minutes. I will be making the server much faster. Okay, it's upgrading right now. If anyone's trying to access the challenges, to be down for a while. Okay, while it's upgrading, it's taking very long. I'm gonna continue. You can do the demo later. Yeah. Okay. We'll do the demo. We'll do the demo later when my server is decides to come back. Okay. But then the mic died. Can you hear me without the mic? Am I loud enough? You guys at back, can you hear me? The mic kind of died.
Project your voice.
Yeah. Okay, I'm just gonna use not use the mic. It's more convenient. So yeah, okay. So earlier we were doing union-based SQL injection. That was the union selecting, right? Actually, anyone doesn't really understand what's going on. I want to re-explain so that everyone's on the same page. Okay. Yeah. Before I go on to blind SQL injection, because this one is going to be using quite a few of the concepts that we've used in the first two, the login SQL injection and the union select. So before I go into this one, I want to check if everyone is on the same page. So if anyone doesn't really understand, it's mic. I press it. Thank you. Yeah. So anyone has any like questions about the earlier stuff? Sorry? Manual. Yeah. 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 What's your question? The login one. How do you find the? Okay, I don't really understand. Okay, let me come over. Yeah. I want to make sure everyone is. Yeah, it's done. I'm upgrading the instances, so yeah. The code is not necessarily in this case I give it to you, but sometimes they don't give you. So you need to know how to identify that there is injection, injection, and then how to enumerate and stuff. Yeah. Anyone else? Oh, okay. Okay. So now, our union-based SQL injection, we depended on the query output. So in the challenge earlier, we have a table where it outputs results in plain text, right? But what if we cannot see this result? Because it's not always the case where our injection vector is returning all the rows, as in, it's not always the case that we can see all the rows that are returned by our query, right? So an example is like, if you are doing the login from earlier, there's no table per se that's returned from the login query, right? But there is still a result that we can observe, right? So if login is successful, is it's a binary output. If login successful is true, if login is unsuccessful, then it's false, right? So this is still something that we can sort of like glean information from. So yeah. So based on this this binary output, right, we want to be able to query an arbitrary length string from some table lah. The same way we're doing for union select, but instead of being able to just join the results directly in, we want to use this binary output to read information. Yeah, so we need two primitives for this to be able to work. The first one is we need to know how we can incrementally query a part of a string. So I will show you an example of this later. Why we need this is because let's say you want to guess a string ASDF, right? You want, I mean not guess, you want to convert this string into binary output, right? You can do it one way. You can say that all strings that don't match ASDF will be false, and then only a string that matches ASDF. So ASDF equals to ASDF. That will be true. But you're going to need to guess a lot of characters, right? Because you need to keep changing your string. So like I guess AAA is not equal to ASDF. I guess AAB is not equal to ASDF. Then I need to keep doing this until I eventually land on ASDF, and it takes very long. So what I mean by incrementally querying it is that I want to query part of ASDF. So let's say I want to query the first letter of ASDF. So that reduces my search space by a lot. I just need to query characters from A to Z, lowercase and uppercase, and then numbers, maybe digits. So once I know that the string that I'm looking for starts with ASDF, starts with A, I can move on to the rest of the string. So I look at the second character. I want to guess what the second character is. So I guess is the second character equals to A, it's not equal to A, not equal to B, it's equal to S. So I know the string is AS. And that's our first primitive. We need to be able to query a string incrementally. And the second one is related to the first one. So I will show you an example here. So this is what gives us our first primitive, the substring function. So the substring function, if you use like Python, JavaScript, it's quite similar to how you can slice a string into a substring, right? But in this case, yeah, okay, so the syntax is the order of the arguments is the string followed by the position or the index that you want to start at, and then how many characters you want after that. And this function is actually one index, it's not zero index. So the position parameter, if you want the first character, it will be you have to set position to 1, right? So yeah, so the first example over here, it will select starting from the first character, the next two characters. So it will select AS. That will be the substring that's selecting. And then instead of supplying a string, you can also supply a column that contains a string. So this will be useful in here. So let's say we are selecting username, right? So let's say we are selecting username11. You'll be selecting the result of this will be just U and then A, because you're selecting only the first character. Yeah. And this is the second primitive that I was talking about. So we can actually use a select subquery inside the main query. So this only applies for certain types of queries. I don't really know like the exhaustive list of queries you can use for, but you can put this select query in parentheses. You'll run this query first, and then you pass the output of this query into this into wherever you insert it, and then so let's say select ASDF, right? You select ASDF, and then you put ASDF over here. So your main query will now become select username password from users where password equals ASDF. You can also do this for I didn't do example, but you can also do it for column tables, like how you usually do a select query lah. It's the same thing. Yeah, we don't need to go very in-depth with this because it's not too important. Okay, so for this blind SQL injection, we are now going to go back to the first example. But instead of just simply logging in, right, we want to lead another value from another table. Similar to how we did it in union SQL injection. And I'm going to show you the table that we want to target. Yeah, so that's the second. You can wait now. Okay. Okay. We want to select the flag column from the flag table. So this one, this is the flag column, right? From this flag table, and we want to select this on the remote. And our primitive is logging in, like so. I mean, this is the injection vector, right? So in here we cannot do the union select because, as I mentioned, we don't have text output from this query. You only have a binary output, true, false. So yes, this is one of the payloads which we will be sending. And it looks kind of complicated, right? But let's break it down. So we start off with the username one is not important. So we'll be trying to log in as user1, where the password is a blank string. So this will never pass, right? So if the condition afterwards is false, then we will not be logging in. But if this condition afterwards is true, then we will be logging in. So that's our binary output. And we are using, we are doing it on a substring. I mean, this condition is to a substring of the flag value from the flag table to just a single character. So this is going to check if the first character of the flag column in flag table is equal to A. If it's not equal to A, then like so, it's going to fail. You're not going to be able to log in, right? And then now what we can do is we just keep changing the character. So we change it to B, and then it happens to match B. So we manage to log in, right? And then we can keep doing this. So once we find the first character, we move on to the next character. So we change the position. In this case, we can change the length also. So we change the length parameter to 2, and we set the first one to B, and then we check the second character. So now we keep doing this, and then once we find the entire string, eventually you'll be able to find the entire string. So you may not know how long the string is, but you can just keep iterating through until you have you've leaked sufficient amounts of info from your table. I want to demo this, but let me bring the challenges up. In the meantime, you can ask me questions before I demo this. Yeah. Sorry?
How do you apply this?
Yeah, I will demo this later. And the challenges up. Yeah, I brought it down there. I'm doing it now. Also, I think like too many people are accessing it, so like it's quite slow. It's not crashing. It's just the network throughput is very slow. Yeah. Okay, I closed it because I'm setting up the challenges.
Yeah, that's right. Just the it's correct.
Because
Yeah.
when you disconnect, can you bring up the
Oh. Okay. Then how do I bring it back? It's just how do I bring it back afterwards?
this height?
Just hide it. Okay. Okay, it's coming back soon, I hope. Any questions in the meantime? Free to ask. Okay, I'll demo this right now. Okay, I'm very excited to announce that I am now spending $84 per month for my server. But that was the biggest side of it. Okay, let's do the challenge. Okay, so yeah, okay. I'm gonna do this blind SQL injection, but I'm gonna use Burp for this because there'll be a bit of auto. Sorry, I forgot to share this. Okay, it's coming soon. There'll be a lot of automation involved in this because we need to keep querying, right? Then it's like we need to change the query permanently. So I'm going to show you how to use Burp Suite to actually do this brute force. Yeah. Let me switch the. I forgot to show the. Yes. It is now. Okay. If you don't have Burp, it's okay. If you have Burp, you can try to follow along. So, it's a bit small, right? I don't know if I can increase the font size. Give me a second. Oh, I can. Oh, I can. Sorry, it's quite small. I don't think I can. Okay, I can't increase the font size, but you can follow along after, I guess. Okay, so I'm going to use Burp here. So I just made a query over here to the login page and then it didn't succeed, but I'm going to do the line SQL injection. So the first step is to send it to the Burp repeater. So the Burp repeater allows me to repeat like post request or get request. So I can send it. So it will just repeat the query lah. As long as then you can see invalid. Yeah, whatever. Okay, now I will be editing the password that I'm sending. So let's try a basic the login bypass one first. Okay, so single quote or 1 equals to 1 dash dash apply changes. So once you put in your payload here, you just apply changes and then it will automatically update your request like this. Then click on send, and I should see that I am able to log in. But this is not the flag that we want. This was the first flag, right? You want the second flag, yeah? I can't zoom in, sorry. Yeah, it doesn't allow me to. If you want to follow along, I actually can't zoom in. Like it doesn't allow me to. Sorry. Sorry. It doesn't work. Okay. If you want, right, you can go to the YouTube stream to see this because I think it's you can see it from the YouTube stream. So if you want to follow along on your computers, you can check over there. Okay. Oh, this page. So I'll go through again. So you open up Burp Suite, you go to proxy. So the proxy tab here. Then you go to open browser. Then you open this Chromium browser over here. Then you just this is just a regular Chrome. So you just put go to the website. Then you just send a request first. So send a login request. And then now if you go to under proxy, HTTP history, you should see a post request here. And this is the request that we want to repeat. Right? So after this, you select, so you highlight this request, then you click on highlight this request, press Ctrl R. This will send it to the repeater tab. So it will create a new window, and then it will allow you to basically repeat the request over and over again. So this is a repeater tab. Okay. Then from here, you can click on the repeater tabs here. Okay. Then you can see there's this window over here, right? You open request body parameters. So in this case, our payload is in the body parameter, that's why. And then you click on the arrow next to password because we are attacking the password parameter. And then now we change it to whatever we want. So back to the payload earlier. 1 equals to 1. Apply changes, send. So now we can log in. This was the very first challenge that we did earlier, right? But now we don't want this. We don't want this one. We want to use this login page to guess the flag, right? The second flag. So I'm going to copy the payload over. This is the payload we're going to use. This is paste. Okay, and then I'm going to change the thing over here. Okay, so I have the payload in here already. Sorry you can't see, it's very small, I know. But so let me update. 5,000. Guys, the port number for this one is 5,000. It's the first challenge that we did. Yeah. Oh. There's an error. That means our payload was wrong. Oh yeah, sorry, there's no. Okay, we have managed to execute the query here. So this is the very first request you can send. So select flag from flag. So I have to change the sub query here, right? Select flag from flag, and then we check if the first character of flag is equal to A. In this case, we know it's not equal to A because it didn't pause it, right? So now let's change it to B, but I'll just change it to B. Then let's see. Okay, login success, right? So now we know based on this binary output, we know that the first character of flag is equal to B, and that checks out because our flag format starts with B, so we know this is correct. So now let's go ahead and automate this. I'm not going to guess every character manually, right? So to do this, we send this entire. So now we have this request in repeater, in verb repeater. We send this request to verb intruder. Intruder allows us to do these kind of brute force attacks. So to do this, press Control. Select the. Just click on the repeater tag, right? Make sure that the query that you want to send is inside repeater. Send it to intruder using Control I. So press Control I, and then intruder should pop up here. And you can see, yeah. So you can change so there's a bunch of attack types in intruder here. The one that we're going to use is called cluster bomb. So you can look at the description for each attack type under, it's over there, yeah. So cluster bomb, what it does is, it allows you to iterate through multiple positions in your page. Okay, I'm not gonna say it's not important to know what it does. So change your attack type to cluster bomb. Then in your query, right, go to the spots, the places that you want to change where you want to iterate through values. So the first one is at the B. So we want to change the B. We want to change the character by guessing. So once you're at the position already, click on this button at the right there, add the symbol. I don't know what the symbol is, but this will insert a new position for you to brute force. So add this thing. Click it twice. So everything that is inside this thing. Sorry, my screen is a bit. Everything that's inside the payload markers will be replaced by. It's like a placeholder value. You're going to brute force it up. The next one you want to brute force is the the position parameter. So put another one here. Okay. Then now, once you've inserted the two places where you want to put the payload, right? In all this video is here and here. Once we have those two, we switch our tab to the payloads tab. So now we are going to configure what payloads we are going to brute force in these two positions. And by default, you can see that now we have two payload sets. We are looking at the first one first. So the first one earlier is the position parameter. So we're going to brute force the position parameter. And we can click on add from list. So there's a list of predefined payloads that verb intruder gives us. So we click on add from list. Then we click 0 to 9. Yeah. 0 to 9. We can. Actually, let's put one more. We can put one more. Okay. Let's not use 0 9. Sorry. Okay. We can change this to actually numbers. Yeah. So this will brute force numbers, and then we can change it from 1 to say 30. Setting once. So this will allow us to put in at the position parameter. We're going to brute force from 1 to 30. Okay, now we configure the second payload set. The second payload set, if you recall, is the letter that we're guessing. So the character set that we are looking at right now is lowercase a to z, uppercase a to z, numbers, symbols, and basically any like printable letters, right? So let's add it in. Add from this. Now we can use lowercase a to z, lowercase a to z. Okay, a to z, 0 to 9. Symbols. Okay, symbols is not defined in bulk intruder, but if you want, you can. I have it. I just have it here because it's quite a common thing. So, yeah, it's not important where you get this from. Then remove the. Yeah, this. Okay. Okay, we've configured our payload now. So our first payload, just to recap, our first payload is going to brute force the position parameter from position equals to 1 to position equals to 30. And the second one will be brute forcing the character from lowercase a to z, uppercase a to z, 0 to 9, and a bunch of symbols. So this one, yeah, this one. So it will be the position. This is the position parameter. This is the letter that we're guessing. Okay, that's all we need to do. So now let's run the payload. So you can see that it already counts how many payloads it will generate. It will generate 2.6k payloads. So like if I were to do this manually, I think we will not be able to finish. Okay, another thing we want to do is we can go to the resource pool tab, create new resource pool, and then okay, but if everyone in this room does this, my server will probably crash again. So maybe don't set it to 999, but this will make it such that our brute force is faster. It will just do more requests at the same time. Yeah, that's all. Then let's start that time. So it's going to try this thing on all the payloads you generated. And is that okay? Okay, so looking at the okay, we sort by payload one. So let's verify if our thing works. Okay, so we know that the first character is b, lowercase b, right? So if you look at your payloads, at position 1, lowercase b, you can see the length is different from the rest. The rest is like 369. Okay, for those who can't see, I'll just read out for you. So the length of an unsuccessful payload is 369, and the length of a successful payload is very different. It's 224. Makes sense, right? Because the output that we see from here, this is the output of a successful payload. This is the output of an unsuccessful payload. So you can see that there's a lot more like text. And so this is the binary output that we're going to use to identify a successful payload. So now we can go ahead to filter. Yeah. What's that? Okay. Yeah, sure. Okay. Yeah. Okay. So we filter. Sorry, we sort by the request length first. Actually, no. We can just do this. Yeah, sort by request length. Then you will see all the successful payloads already, right? And then you can see it's B L A H A J open curly braces something here, right? This is already the leak string lah. We already leaked the string successfully from our intruder attack. Usually at this point, I'll just open up like a notepad or Vim or something. Then I just like copy the letters one by one. Yeah, I don't know if there's a like fast way to do it, but that's what I do. I just open notepad. Fine. Okay, I just open notepad. And then just type it up. BlahajCTF, open curly brace, and so on. So we can already see the leak value here. Blind, BLIND _SQLI. score, and then so on. Yeah. Another way to do this, right, is if you don't want to, like if your string is very long, you can do this in Python instead. So instead of using verb suite, you can use Python to do the brute force, and it's more flexible also. You can customize various things. I will not be doing it today because Python wasn't one of the prereqs. But if you already know Python, you can. I think you can do it quite easily. So you just use Python, then you concatenate all the successful characters together, and then you get your flag. Yeah. If you want, you can open a ticket, and then I will send you like boilerplate code for this challenge to do it in Python. Okay, so for the benefit of those who missed out on some stuff, I will be repeating this step by step again, but quite quickly. So discard attackers. Okay, I'm going to repeat everything from the start. So open the proxy tab, open browser, then you open the browser here. Go to the target endpoint. Okay. Go to the target endpoint and then issue a request. Okay, issue a request. Everyone following so far? No? Go to go to Box Suite, go to the proxy tab, click on the open browser button, and then it will open this browser here. Yeah. Go to the browser tab. Go to your browser. Make a request to the endpoint that you want to attack. So in this case, the login. Just try to log in. Then this will generate the request and put the request inside your HTTP history. Then go back to your verb suite. Go to HTTP history, and then go to the latest request that was made. This will be the request that we want to use to repeat the attack. So after that, click on the request, then press Ctrl R. Ctrl R will send this to the repeater tab, and then you can see repeater will light up. Repeater. Okay, and now it's in the repeater tab. On the side, we can customize we can change the query parameters that you want to send. So, open this request body parameters box. Click on the arrow next to password and change the value. So, I won't repeat the. I will repeat this. Then just type in your payload. Yeah. There's a small errata in the slides. You need to put. I forgot to put the parentheses around the subquery. So you need to make sure you put the parentheses. Yeah. I'll update it later. Okay, so back to here. Put the parentheses. Change target the table that you intend to read the value from. Change the substring parameters and set the character you want to get. So I've edited everything inside that. You can see that over here there are two boxes here, right? Actually, three boxes. The first box is the name of the body parameter you are attacking. Second one is the raw value. This is the raw value that you're putting into the press. Yeah, the raw value will appear here. This is the raw value. But you can see all these weird characters like, okay, you can't see from there, but it's like %20, %2C, whatever, right? This is something called URL encoding. So it's not important what it is, but we don't want to edit the payload directly like this because it's encoded. So we want to use
we need to decode it first. So box you actually put another box only for you to decode it from your encoding. And then you can just edit this directly. This is the nicer form of our payload. But the value, this value box is the actual payload that we're sending. But it's all done for you in Boxy, so you don't need to worry about it. Yeah. Oh, I copied it directly from the slides. So you can use this slide. Yeah, slide number 35. This payload. You might need to change it to like this. Yeah. Okay, but I don't encourage you to just like copy payloads like this. I in this case it's convenient because the payload that I'm using here is really the correct payload. But when you're doing your own, like you're doing other challenges, the payload, you need to write your own payload. It may not be the same payload that works. So you need to write your own payload. So it's better to understand what this payload is doing, and then so that you can make your own payloads. Yeah. So, but for now you can just copy it. Okay, okay, so everyone following so far? Now we are at the repeater step. So we will be checking if our payload works. And if we send it, did the server go down again? Oh no, it's still up. It's still quite slow, but yes. So if we send the payload, if you send the request, you should see that login success. You shouldn't see internal server error. If you see login fail, it's still okay. It could mean that your first character is not the correct character. But if you see internal server error, it means your payload doesn't work. So you need to go and modify your payload to make sure it works. Yeah. Internal server error. Oh, is it loading? Try sending it. In those of
Okay, everyone following so far? Oh, wait, we have more people.
Yeah, but I mean, for anything else, it's really
I didn't know
small.
that.
You
I
can
didn't know
use
those
it.
things. Okay, I'll be moving on from this. I will not be using worksheet anymore. So I have bigger font sizes. Okay, this is just for extra stuff. So earlier we still had one output. Our output was being able to log in or not being able to log in. But if we go one more step further, right, we can have no output at all. So we issue a query, but the query doesn't even tell us if like it returned a row or it didn't return a row. It just executes the query and returns nothing to us. But we still can get a binary output from this. So this is specifically for SQLite. You can find more payloads for MySQL, Postgres online. There are more payloads for this, but this is for MySQL. So we have this function called the if function. This if function it takes in a condition. So this is the condition. If substring 11 flag equals to b, this is the condition. If it is true, perform the action here. So there'll be you can put more code in here. So it will run this code.
If it is not true, it will run this code. Yeah. So, why this triggers an error when it's true, right? This load extension, you don't need to know it in detail, but it's trying to load extension 1, and this extension doesn't exist. You don't need to know why it creates an error, but it just need to know that it does create an error. So using this, we can force the server to return us a binary output, even if it doesn't actually return any content in the first place. So by triggering an error in the SQL query when a condition is met, we will be able to observe a binary output. Yeah. Okay, yeah. I don't have any challenges for this, but you can try on the login one if you want. Okay, so how do we mitigate SQL injection? Actually, any form of injection. We can do sanitization. So what sanitization means is that we take we look through the payload or the input that someone is sending us. We look for all these special characters. So like in our SQL injection, a special character would be the single quote, right? So we find single quote. In command injection earlier, we have a lot of special characters. We have like the ampersand, the pipe operator, semicolon, and backticks, and so on, right? We take all these special characters. Either we remove them from the query, which is not ideal, or we can escape them. So escaping is the second one. Yeah. So sanitization, okay, we can either remove them or we block the request directly. Either one works, but this is not the ideal solution because let's say for our command injection, if suddenly we have a new symbol that allows us to escape the content field, right, and then go into the code field, it will not be detected by our sanitizer. And it can also block legitimate requests that we want to make. So if let's say our user's password was actually a single quote, right? And then he wants to issue that password, but he cannot because our sanitizer will just block the single quote. Right? So sanitization is not the best way to do it. The better way to do it is to do escaping. So escaping allows us to or prepared statements in the case of SQL. Basically what this does is it looks through your input for all these special characters. Instead of removing them or blocking the request, we instead put another character before it to tell our SQL engine that this is a special character inside the input and not inside the code. You can Google to find out more, but this is not always foolproof. There's actually a very recent CVE that was found in a legacy adapter, and I'm going to show you. So in this CVE, right, someone managed to get SQL injection even inside a prepared statement, and it's quite dangerous because like your developers nowadays they are trained to always use prepared statements, but they may not expect that this kind of CVE will appear, and it's loading, but it's very slow. I don't know why it's so slow. No, I'm not in Burbank. I don't know why it's so slow. Yeah, you can read more about the thing in your own free time. I will go back to the slide. Anyway, they managed to supply a certain input into the any SQL prepared statement, right? So prepared statement should not be vulnerable, but they managed to find an input that actually allows them to still do SQL injection from there. So yeah, quite cool. Okay, before we move on to the next one, okay, we don't have a lot of time, but we can take a short break first. So let's take a break until 2:10, and if you have any questions, you can go ahead and ask me. I will try to help.
If you want to go to the toilet, you can also. Yeah. Yeah, it does. Any more questions? Oh yeah. Yeah. Okay. I will be moving on to XSS, and I think this one will be slightly easier. I hope. Okay, how many of you know like HTML or like just a bit of HTML? Okay, not bad, not bad. Okay, it should be doable. Okay, so okay, before we go into how to do XSS, right? We want to look at why we want to do XSS. So, XSS, this specific injection that we're doing is no longer on the server side. Earlier, command injection, SQL injection is all on the server side. But there's another side of a web page which is your client side, and that is where your HTML, CSS, and JavaScript, all of these stuff exist. So when you visit a website, let's say example.com, if he has JavaScript that he wants to execute, right? He can execute all this JavaScript, right? But it doesn't mean that this website can do whatever it wants. The browser will control what the website can do, what the website can access, and what it cannot access. So, it's something called browser sandboxing. It's not very important, but basically, because of this sandboxing, sometimes you want to, as an attacker, we want to execute JavaScript in the sandbox of another website, not in another. We have a certain sandbox that we want to target. So the goal is to be able to execute JavaScript inside the sandbox. And the only way to do it is to make example.com or whatever website you're attacking supply JavaScript, arbitrary JavaScript for us. And that's actually a very difficult thing to do because we don't have control over example.com. We cannot control what it wants to send to the user. But if example.com is vulnerable in certain settings, we can do this. And okay, yeah, and in the sandbox, what we want to access is most of the time we want to get cookies. So I don't know if you've seen like the cookies, you accept cookies from in like websites and stuff. Cookies are string values that are stored inside your browser. And these string values, they are used for a lot of things. They are used for tracking you on the internet. They are used for logging in to maintain login session so that every time you create a new request, you don't need to re-log in. You just use a cookie, and then the website checks if you have a valid cookie. If you have the cookie, you can log in. So you can really see if cookies are used for logins, right? If we steal the cookie, we can log in as another person, right? So okay, there are some kinds of cookies. So there are different kinds of cookies. A HTTP only cookie cannot be accessed via JavaScript. So it's only sent to the server. So if a cookie is HTTP only, we cannot access it. We usually cannot access it via the client side. There are certain caveats, like some challenges have HTTP only cookies that you still need to steal. It's out of scope for today. So we'll only be looking at regular cookies, not HTTP only cookies. Okay, so one of the goals of cross-site scripting, XSS, is to exfiltrate cookies, but we can do other things also. We can perform elevator actions on behalf of a user. So in the context of, let's say it's an admin portal, right? And we have XSS in the admin portal, we can get the admin to do actions that the admin didn't intend to do. Like, we can make a post request to delete user or edit user or something. And then we can do things for the admin that the admin didn't intend to do in the first place. And all this is possible because we are executing JavaScript in the sandbox, in the context of the, in this case, the admin portal, when the admin is already logged in, right? Yeah, and we can retrieve sensitive data also. So we can, let's say there's a secret document that the admin is reading, right? If you are able to get access in the document, we can also read the document together with the admin. Okay, and we're back to injection. So now our injection is in the client side. It's in HTML. So these tags over here, this is the P tag. You don't even know what it is, but it's supposed to put text in here. It's not supposed to put code. I mean, you're not supposed to be you're not supposed to be able to inject HTML syntax into the input. So ideally, okay, let me show you. Okay, so this is a very basic, very classic XSS payload. So we introduced a new tag here. This is the script tag, and the script tag, whatever is inside the script tag, will be executed as JavaScript in the browser. So this one will execute the JavaScript function alert, and then it will just create an alert lah. And in here, the special character that changes our input from content to code, right, is there are these angle brackets here. These angle brackets is how we specify, how we create HTML. I don't want to say HTML code because it's not code, but HTML like syntax. This is how you create a new new something, new element, yeah, new element in HTML, yeah. So earlier, if you want to prevent XSS, right? That's how we want to prevent SQLite. Now we want to prevent XSS. We need to make sure that these tags these angle brackets are not are forbidden, are not allowed to, are not. We don't allow the user to put these tags inside. Yeah. So okay, let's do a demo. I don't know how slow my thing is right now. Because some of you had some issues, I think, but it seems okay. Let me know if it's too slow. Now we are on the third challenge. So on port 5002, and let me download the disk as well. Okay, let's take a look at the source code. So this is the source code in the challenge. We have just the normal index.html here. This is the page that we first see. That's the HTML. We have an endpoint where we can make a post request. So this allows us to create a new post, and then we can view the contents of our post. And I'm just going to gloss over all the Python stuff because Python isn't part of today's lesson. But if we look inside post.html, this and this is where our input is going to. So content is going to these div tags over here, and then image is going to here. So image we'll look at later. Now we are going to focus on content first. So let's try to make some content, make some image, and then let's look at the oh dear magnify. Okay, it's still too small, right? We don't need that. Okay, I'm going to go over to the. So everyone here knows how to do inspect element, right? Just press Ctrl+Shift+I or right click on the page, and then you can click on inspect. Yeah. Then once you're inside inspect element, it depends what browser you're using, but there should be a tab called elements with this thingy looking over here. It depends what browser you're using. Then open it, go to your thing might start like this at first. Then open the body tag. So click on the arrow here. Then you can see the div tag should contain the content, and then the image tag inside double quote should contain your image URL, whatever you specified it. Okay, anyone lost so far or like okay, yeah.
Anyone have any problems? Yeah. Okay. Surrounding of the payload, and then it's just our event. So let's try to put script alert one script into our div text. So go back to the previous page and you just input your payload into content. And now we have a new box and alert, and then it's alerting us with 1. So this is how we identify that there is XSS in a certain page. We just put in our script alert 1 script, and then if we load the page and then we see this pop-up, this pop-up doesn't appear here, right? But if we are able to get XSS, this will be the pop-up that we see. And if we go back to the inspect element, you can see under the div text, now there's a new element here, this alert 1 element. And this element is being, the contents of this element is being XSS. We already have, we can inject arbitrary JavaScript into this page, right? Okay, so alert 1 is not very useful. Like alert 1, you just put a box and then that's all right. But maybe if you want like prank your friends or something, then type document.cookies, cookie, just cookie. And then document.cookie is a string that, let me zoom in for you. Yeah, so document.cookie is a string that contains the name value pairs of all the cookies pertaining to this this web page. So how do we exfiltrate this string? We want to get the value of this string from some user lah. So okay, what we're going to do here is we want to send. So we want to take this link, right? We take this post link. We make our victim visit this link. So when he visits this link, we can execute arbitrary JavaScript in the context of his browser, in the context of this web page. And then we will be able to access his document.cookie, and this document.cookie contains the name value pairs of, say, the admin's login token or something. You don't have to, but in this case, I just put value. So my cookie is a cookie name ASDF with a value. But if you don't put that, it'll just be an empty string. Like it'll just be like this if you don't put any values. Okay, anyone not following so far? Any questions? All good? Okay. So how do we exfiltrate this? Now it's very easy for us to see, because we are the victim. We are just attacking ourselves. Right? We can see the document.cookie in our browser. Then if you want, you can do something like yeah, sure. So if you want, we can go back to the alert function, right? Then we just alert document.cookie instead of alert 1. Then we submit this. Then we should see our cookie ASDF something. But this is all on, we're just attacking ourselves. Why are we attacking ourselves? And if we are executing arbitrary JavaScript on someone else's computer, we cannot see all this output. We cannot see to another endpoint. So what we're going to do is we want to take this string, send it to our own server. So we execute Java, we insert a piece of JS code such that it will send this document.cookie value to our own server.
and then from there we can link the value. So there's this function in JavaScript called fetch. Fetch will basically send a GET request. It can be a POST request, but send a request to a URL that you specify. So let's say I want to send it to you can go to this link called webhook.site. Just go to webhook.site like this. Then you press enter. You create a special endpoint for you where you can like a personal personal endpoint where you can use to link values. So you load this and then you just click on this one to copy your clipboard. And then you go back to right here. Okay, so paste it in, fetch this endpoint, and you just press enter. It will execute. Okay, you don't need you can ignore all these, but it will execute. It will make a request to the endpoint log. Then you can see the request here. Then I have a new request, and this is from my IP, and you can see certain stuff about the request. Right now, there's no details, but you can see the link, the IP, any query strings, the headers, and so on. Okay, back to here. Now, oh yes, okay. Let me get it right now. So, document or cookie is let me just. So this is our document or cookie. This is a string, right? We want to leak this string. We want to send this string to our webhook.site. Our webhook.site is not a string. It's just a string. It's a URL. We can append it to webhook.site. So we just put here, and we put a question mark. So question mark, what question mark does is indicates that the following stuff is a query parameter. You don't even know the specifics, but just put a question mark at the end of your URL, and then put document. Okay. Let's look at it. So if you are following along, right? If you see on the tab, if you see this one like that, right? It means that there was a new request that came in. Not very much, just for convenience sake. And then you can see this one is like bolded, right? This is a new request. Click on it, and then go to query strings. Okay. Now you can see query string ESDF. Just now our document of cookies is the string is ESDF equals, right? You can see over here is ESDF and then some empty string, empty string. Yeah, and then so that's how we are going to leak log. So instead of running this on our own browser, we are going to run this on our victim's browser. And by the way, if you click on submit, right, this submit button, it will send it to a bot, then the bot will visit your page. And the bot's cookies contains the flags. The flag, yeah. Anyone else so far? Yeah. Allow.
I think just rent one LAN cable.
Yeah. Oh yeah. Anyone needs to use the toilet, you can go ahead and but I have everyone here, right?
Okay, everyone good? Everyone good? I'm going to continue. Okay, so we've up to now we've always done our SSS on our client side, right? Our own browser. Now we want to send this to the admin bot. So I'm going to do it now. So just to reiterate, because some people got confused about this, how do I close this? These HTML tags, right? You can see that the HTML tags, an opening tag will look like this. So it will be open angle bracket, then some whatever element type you are specifying, then close angle bracket. This is an opening tag. You can see it for script also. Open angle bracket, some element type, close angle bracket, and then a closing tag is like this. So it's the same thing, just that you have an extra slash before the element type. That's what you know. So this is how you create a HTML element. Okay, I'm going to go ahead and do this thing. Okay, so yes, we can see that our client now sends the cookie to our webhook. So let's go ahead and submit, and it'll take a while because the bot, okay, the bot is later goes, and then get the flag. Yippee! Yeah, so this is one of the most classic like XSS challenges you can get, yeah. What do you mean? Like, okay, I will do this one more time before we move on to the next one. So, over here, right? We put, yeah, I'll make this bigger, wider. So, we put the script text, script, so open angle bracket, script, then fetch. So inside the script tag, we can execute JavaScript. So fetch, the fetch JavaScript function, open parenthesis, quotes, then our webhook URL, followed by a question mark. Then to the end of our URL, we append document dot document.cookie, and then to end it all, right, we need to close the script tag. So angle brackets again, script, angle, okay, angle brackets / script, and then angle bracket. So yeah, okay, then after we send this to the bot, and the bot will take a while to visit our post. Once it visits our post, we go to our webhook site and we can see the flag. Yeah. Can ah? Yeah.
Why does the ball just go?
Oh, okay, I didn't go through this because I didn't want to go into the Python syntax. But yeah, okay, so he asked why does the bot give us the flag like randomly? Like it feels very weird, right? Like so if we go to the this function over here is what is being executed when we send the bot URL to visit. So we can ignore all of this. Just go over to this line here. So line 55. We can see that before the bot visits our page, it creates a new cookie with the name being flag and the value being the flag itself. And on remote the flag is something else. So now at this point, after this line, the bot has a cookie on our page that on domain logo. So remember that a page has a bunch of cookies that is only accessible from the page itself. So in this case, the page is localhost because the bot is just visiting our page from localhost. So if it were to visit, say, example.com, right? Example.com will not have this cookie. Only localhost will have this cookie. And now we go to here, the bot will visit our URL, and then, yeah, that's all.
So the bot visits your local admin server.
Correct.
Yes. Send
Get sent to our web. Yeah. Okay. Let's go a little bit more advanced. So earlier we were just injecting HTML. We are just creating new elements inside the website. But what if we cannot create new elements, right? So there's a lot of XSS vectors. One of the vectors is just this. Another vector is we can inject attributes. So this is the image part of the challenge. So we can inject the website can be configured such that it puts user input into an attribute. So what is an attribute? This is an attribute. So inside the opening text of an element, right, you can actually specify certain so-called parameters or attributes of the element. And the syntax is the name of the attribute, followed by equal sign, followed by quotes, and then the input that you want to put in. So in the context of our challenge, we can see that here, this is the attribute that we are able to inject. Right? We can put user input into the source attribute of an image. Okay, so now our injection vector is slightly different. Just now, how we change our content to code is by putting angle brackets. But now it's slightly different. Even if we put angle brackets in here, it's not going to create a new HTML element. Let's try that. Script. Sorry. Yeah. So you closing. So if you do it like this, right, you can see that it's still a string now. It's still content. We want to change this content to code. So what he said earlier, we can inject quotes instead. So if we inject a quote inside, this is going to close the source attribute. Close the string of the source attribute, and then now what's outside are additional attributes that we can inject. So we can see by inserting a quote inside, right, we close the source attribute, and then now we can inject additional attributes. Actually, we can even escape the element itself. So we can put a closing angle bracket, and then we escape the element. We can inject our own elements, but for the purposes of this challenge, we'll just be injecting attributes, not elements. So, okay, yes, and there are a lot of attributes that we can put inside an element. Let me show you a list of them. I think I have it here. I don't have it here. So HTML elements can accept a lot of different kinds of attributes. So there's a whole list over here. Actually it's not very long list, but there are a bunch of stuff. And in addition to attributes, right? I mean, in addition to these static attributes, there are other attributes here. Are these the ones? Yes. Okay. Here we go. Global event handler attributes. So you can see that all these attributes, they start with on, and then it's like some keywords. Let me zoom in. On abort, on animation cancel, on copy, blah blah blah. So what's happening here is that when we put such an attribute inside any element, the value of the attribute, which is a string, will be executed as JavaScript when the specific event occurs. So let's say on mouse down. So mouse down means that you click on the element. There's actually on click. Actually, let's go to on click. On click, right? So when you click on the element, the on click attribute, the on click attribute's value will be executed as JavaScript. So that's another way to execute JavaScript. So you can see something like, oh, they don't have any examples. I'll show you an example. So anyway, we can hook JavaScript code to execute to a certain event, right? So one of the more useful events that occur is this. Oh, they don't have it here. They don't have it here. On error. Okay, so the on error attribute. On error. Okay, so the on error attribute. Sorry, the error event, right? This one fires when it's a very broad list of events, but one of the events that can occur, and the one that we'll be using, is when the image source is invalid. So when it fails to load an image, it will execute the error event. And to hook JavaScript onto the error event, we can use the on error attribute. So that's what's happening here. Let me close the. Yeah. So over here we are injecting attribute on error, and we are setting its value to alert 1. So like earlier when we did alert 1 in the script text, right? You create a new box with the you create a new box out, yeah. So in this case, instead of using the script text, you'll be using the on error event handler, and then you execute alert 1 when it fails to load ASDF. So ASDF is not a valid source URL. So yeah, so you execute your thing. Oh, it was here. Okay. Yeah. Okay. Let's do the demo. So back to here. So let's pretend that we don't have the content vector anymore. So we cannot use this to do our exercise. So if you recall, we need to put double quote first, right? Double quote, then on error. So double quote space on error. So now on error is the name of the attribute we are going to inject. Put an equal sign. Open the quotes again. So now we'll be putting the value of the on error attribute. And let's just do alert 1. So, and don't close the don't put another double quotes at the end, because if you recall, we started off with so our we have double quotes in front and behind of our payload. There's one here, there's one here. So this extra quote, you use it to close our injected one. Yeah. So back to here. So this is the payload we're going to do. And then let's do EST. We have the alert. So it happened very fast, so we cannot really see what's going on. But if we go to the image element, you can see that it tried to load source ESDF, it failed, and then it fired. Yeah, it doesn't show here. So okay, the rest is the same. So now we just replace alert 1 with the payload from earlier, the fetch payload. Everything else is the same, because now we can execute arbitrary JavaScript. So we go ahead and put the fetch payload. Okay, one more thing here. Because we are using double quotes to like double quotes is a special character, right? We are using double quotes to escape content and inject code. So when we are writing our fetch function, we cannot use double quotes again, because if we use double quotes, this is just going to close the on-error attribute, and then everything else is going to be outside of the on-error attribute. So we have to use single quotes. Yeah. So JavaScript we can put strings by using double quotes or single quotes or backticks. In this case, you're using single quotes, and then copy our webhook, copy the URL, go back to here, fetch question mark, single quotes, plus document close. And then there's nothing else to put after, because it will be the closing quotes of the on error attribute. And send. Okay, let's double check first. So on error equals to fetch plus document. Okay, that's correct. And you should see now we see the exact same thing. Let me zoom off it. We see the exact same thing from earlier. And then our cookie, the ESDF cookie is here. So just do this on the remote, send it to the bot, and we'll get our flag. XSS. The first way, two ways to execute arbitrary JavaScript. First way is to inject a script tag, and then put your JavaScript code inside the script tags. The second way is to inject an attribute and then put your JavaScript code inside the attribute. So yeah, those are two common ways to get XSS. Okay, at this point, I'm going to take another break. Anyone have any questions at this point? I may have gone through a bit quick on this. Any questions? If you don't have any questions, you can go ahead and try, or if you try already, then you can take a break first. Or if you haven't, then you can go ahead and try the payload on the challenge itself. We will be back at 3:18, because we are running out of time. 3:18, we'll be back. If anyone needs a toilet, you can go ahead. I'm not sure. Is it laggy?
Some guy said.
It's just now the. I think it's on TNETS. I thought the event is now. What's the Wi-Fi?
iPhone.
Okay, sorry, I overran a bit, but we are back. Okay. CSS exfiltration. Now just now remember we had HTML, JavaScript, CSS, right? We've always been dealing with HTML and JavaScript. We haven't really touched CSS yet. So let's imagine that we have a certain endpoint that allows us to specify arbitrary CSS. Can we do anything with this? So CSS, just to briefly cover, CSS is how we have our colors, our shades inside your browser, inside your web page. So like all these nice rounded radius, all these icons, it's mostly created, and it looks something like this. Okay, I'll go to this one, then I'll look at the CSS. Sorry, on the okay, never mind. I will look at the CSS. But you can probably see then let's start off. And we have some CSS here. So I don't know what the CSS is doing here, but let me zoom in. So this thing over here is CSS, and similar to script, we need to put style tag around it. So just now to put JavaScript code, we need to put script tags, right? So now to put cascading style sheets code, we need to put style tags. And then we put style around it, and then we specify some content inside. The content will be executed, not executed, but it will be interpreted as CSS. And you can see it's like some complicated stuff. I also don't know what it's doing. Anti-cloak something. So all this is doing is changing the look of your web page, right? Can we really do anything with this? Like honestly, I can make a web page look like really ugly, but I can't really link anything, right? Actually, not right. So we can okay, this is very similar to blind SQL injection. So we can induce a true false or like just now the binary output thing using this CSS attribute called background image. So background image will try to load an it will try to load an image from a certain URL. So you can see like here URL attacker.com. It will send a GET request to attacker.com and then try to load that as the image. It doesn't matter if it's not actually an image there. As long as it can send a GET request, it will send a GET request, and then now attacker.com will be able to see the GET request. So this is the true false lead, right? If let's say we have some way to do conditions in CSS, we can make it such that if it matches a certain condition, then we load the image. If not, we don't load the image. And now we have binary output. So we can go one step further. We can change this true-false lead into straight-up value lead. And how we can do this is, before I go to that, let me show you how to do conditional styles in CSS. So there are a lot of ways to do conditional styles. If you go to the Mozilla, the MDN docs, right, you can see some documents for documentation for CSS. And let me magnify. So example is like this one. So this is the CSS syntax. We are selecting an A element that has an attribute href equals to https example.org. So this will only select all, you can see the comments here, right? href matching https example.org. We can do better. We can change the equals to something like, remember the substring stuff that we were doing? We can match a substring of the attribute. And did they show it here? They don't show it here. Oh, they have it here then. Represents elements with an attribute name of attribute whose value is prefixed, so starting with value. So it's very similar to how we are doing blind SQL injection, but now we are doing it on CSS. So to recap, our binary output, the true-false output, is whether background image is loaded or not. Our condition, in blind SQL, we're doing the condition by checking whether it's equal to some value. Now we can use this thing called attribute selectors here to select part of an attribute. And we can set part of attribute using this character. So here what we're doing is we are looking for all input elements with a href, with a attribute with a name value starting with the letter A. That's what we're doing. And then after that, we can just load background image equals to URL attacker. We can do better. So instead of using binary output, right, this will take very long because we need to send, like so we send value equals to A, then load. Then if it's not A, then send value equals to B, value equals to C, and so on, right? But because now we can, it's not the same as in blind SQLi where we can only do one condition at a time. Now we can do multiple conditions. So we can just put a lot of these rules. So input value starting with A, starting with B, starting with C. And for each one, we load a different endpoint. So let me just do it over here. So instead of loading just attacker.com, right, you can load attacker.com/A/B/C and so on. So every time we receive one character, or every time we receive one GET request, the GET request at the end, it will contain the character that we're trying to read. So so this way, right, we can, instead of sending one request per character, we can send one request per position per character. We can now send a bulk request, and this bulk request contains all the characters you're trying to guess for one position. So I don't have a challenge for this, so bear with me for a while. So let's say the first character is B. So we are going to load attacker.com/B, right? So now we know the first character is B. Then now we're going to guess the second character. So we're going to put a lot of these rules, A, B, C, and so on. And then each one, if it is true, if the second character is equal to say A, you'll be loading a background image at the attacker.com/BA. And then that's how we know the second one is BA. Let me change it. You don't need to know this in detail. I don't think like anyone said change this. So let's go back. Okay, so this is just for your info lah. Like CSS execution, it's quite cool. We can do other stuff also. Instead of using attribute selectors, right? We can even select patterns like this. So it doesn't show here, but we can basically like the CSS query rules, right? It's very extensive. You can do a lot of things with it, as long as the value that we want to leak is inside the HTML syntax tree, preferably in an attribute. It doesn't have to be. As long as it's inside the HTML syntax tree, we can most likely leak it using CSS. We can conditionally query it using CSS, and then use true-false output like background image to deduce whether a condition is met. Yeah. Okay, I don't have a challenge for this, so let's move on. So, last part, right? Yeah. So this is the last part of XSS. There's this thing called content security policy. So, honestly, XSS is a very easy vulnerability to it's not easy to prevent, but it's easy to limit the scope of what the attacker can do. Because your browser is already sandboxing certain things. It's sandboxing, like let's say you want to prevent the website from accessing other websites cookies, right? So it's already preventing you from doing a bunch of stuff. So why not we just update a little bit? We can use this thing called content security policy. So content security policy basically defines the various sources that you can load objects from. So objects include like images, scripts, style sheets, and so on, right? And these are the two ways we can specify content CSP, content security policy. First one is through a HTTP header. So this is the usual way we do it. So HTTP header, we just put a content security policy and then the value of the policy. And the second way is through meta tags. So usually these meta tags are found at inside the header, the head HTML tag. So if you go over here, you can find certain meta tags like this. Yeah, so you can see there's a meta tag here, but it's not CSP, but something like this. And then we specify our CSP like this. Just a good to know, not really important. Okay, so these are some of the more common CSP rules that we are going to specify. So we can control script source, can control image style, and then default source, it will just apply this CSP to all objects. So yeah, all objects. So these are some of the rules that we can specify. So self means that you can only load that object from the domain itself. You cannot load objects from, let's say, attacker.com. And in addition to this, right, the CSP rules are exclusive. It's like a whitelist. So it means that once I specify script source equals to self, I can only load scripts from the domain itself. I cannot do like script tags anymore. The script tags are under this category called unsafe inline. So the moment I say script source equals to self, the only place where I can load scripts is from somewhere from the domain. So like, let's say the website I'm using example.com. I can load a script from example.com/index.js. This one's a special one. This nonce rule, right, is a special rule that allows us to load inline text. So inline text being these script tags, right? But these tags must have a secret nonce value. And this the nonce value usually is not predictable. So we need to generate this nonce value every time we send a request. And so an attacker cannot predict this nonce value beforehand. And a browser will refuse to execute to execute any script tags that don't contain this nonce value. So this allows us to still specify inline tags without allowing any inline tags out. So we only allow inline tags that have this nonce value. If you can predict this nonce value, then it's kind of useless, but most of the time it's implemented well. And unsafe inline access any inline scripts. There is one more way to actually execute JavaScript that I didn't go through. Is using this JavaScript href syntax. So it's a special URL of sorts that allows you to specify the JavaScript code right after the URL. So if you can follow, you can just put in your browser. It will execute one like this, alert one. So this is another way to do to execute JavaScript. Yeah. When this is useful, let's say you have a button or like a link, right, that you want the user to click, and then instead of directing the user to another endpoint, it directs the user to this malicious JavaScript. So that's another way to do XSS. Okay. This one is a bit more difficult. I don't know if we should go through this, but let's take a break first. Anyone got any questions so far? If you don't understand like all the CSP, CSS association, it's okay. All those are like just like pretty cool stuff that I found in some CDF channels. Probably won't appear in calls. Maybe in finance, I'm not sure. Any questions? Yeah. Thank you. how many of you feel like the content so far is like super heavy and like you're super confused? Okay, it's quite a few of you. This last topic over here is actually an additional topic that I want to go through. But I think for now, let's stick to just the first few stuff. If you all want to know more about this one, I will feel free to open a ticket. I will try to guide you through. Or you can read the slides on your own. I think they are quite verbose. You can also go and Google on your own. But right now, what I want to do is I want to go through the important stuff again. So just to make sure that everyone is on the same page. So let's go all the way to the start. Oh, actually, let's do the demo actually. The demo that you wanted to do earlier. We have our first volunteer. Okay, so I want you guys to see that this guy over here is a pro.
I kind of forgot.
Oh, you forgot already.
It's okay. You come back to me.
You come back to me, yeah. Okay. So you'll be going through the first. I'm going to get random people to do the challenges again. So this first challenge, you'll be doing the login bypass. Okay. Let's start.
Okay.
Basically,
if I can remember correctly, it's an SQL-like injection attempt. So I know if I put a semicolon here, it can bypass. Then so I put an OR, 1 equals to 1. So this is how do I explain it?
it's like adding additional condition there.
Yeah. So basically, this adds a condition such that password returns true, and yeah, and I need to remove like random stuff from the back.
The comment. That's what comment.
Yeah, it's a command to like remove excess stuff. So it just guarantees that this string, this argument returns argument for password returns true. Yeah, so it should work. Yeah. Alright.
Yippee! Guys, clap. Okay, second. Oh, my bad. Second one is union select. Who thinks they are confident enough to do union select? Anybody? Someone from the back. Someone from the second last row. Someone from the second last row in the third seat from the right. Third seat from your right. The dude in the jacket. You're not confident? You can phone a friend. You can phone a friend for help. I'm not your friend. Oh! Well, no, wait. I also don't know how to do. I forgot already. So I need someone else to help. Yeah. I'll phone another friend. Who? Oh, okay, yellow shirt guy. Okay, let's go. Okay, are you confident? You know how to do?
I think
Okay,
this is the union SQL.
yeah. Okay, so he's part of work here. He's doing a substring. Is it right or is it wrong? We'll find out. Ooh, selecting asterisk. Select.
think this is the wrong one.
Okay, he thinks it's the wrong one. He's gonna try again. Let's see. Union select.
Can I see the source code?
Okay, he's gonna see the source code. Let's go to the source code. Yeah. Okay, this is the fragment, and then this is the so this is the table, and then this is the okay. Okay, so right now he's looking at the source code. The query is over here, and the query is select asterisk from post where username equals to our input. So what we want to do is we want to use union select to get the flag from another table, from the Blahaj flag table. So I think he's got it. Select now, select him, select flag for Blahaj. From Blahaj flag. Ooh, there's no output.
Oh, wait, I didn't.
Right. We forgot to escape the username. So we are gonna go book and everything should be right. Let's go comments. Yeah. Woohoo! Clap, clap. Okay. Not so difficult, right? Quite easy, right? No? Very hard. Okay, I'll skip the blind SQL injection. I think that one. You all want to do? Anyone want to do? Yeah. I don't know. I didn't set web. I set phone. This is not phone. This is web. I don't know what challenges are in the what challenges were set for web, but something similar will come out, I think. Sorry? Okay, what? Oh, you want to use the not here? Okay, anyone wants to do the blind SQL injection? Honestly, this kind of optional. If nobody wants to do it, then I'll pass. Yeah, so I'll let you use my Work Pro, and I'll guide you through it. Anyone wants to do it? No? Okay, let's get that one. That one is honestly one of the more difficult ones that we're doing today. Let's go to XSS. XSS. Okay, XSS. Script tag injection. Who wants to do this? You need to go all the way. I will not accept you just showing me an alert box. I want to see the cookie appear in my webhook. Anybody wants to do this? Yeah, I'll choose someone from the front this time. It's the one that pop up. Then afterwards, you need to send a query to your webhook. To lead the key. You want to do it?
Because my web
Your
web just keeps it's like why so long?
strange. Maybe your one won't work, but it will work on mine. So you should try on my computer. However, yeah. Okay.
It's inside here,
Let's
right?
do it. Our cookie is in front. Yeah. I'll calculate it. Okay, it's inspecting. And then we can see, okay. We have a cookie right now. We have a cookie ESDF with an empty value.
Let's pick another one.
Okay, he's gonna make another cookie. So it's gonna be a whole cookie. The cookie ADDF. ADDF. Very cool. Then
Remember something from the slides. Or was it from the slides?
yeah. Good. Okay, he's checking the slides right now. Okay, we have the payload here. Script alert 1, close. It's gonna copy it. It's gonna paste it. It's gonna hack it. Okay, we have our JS execution. Now we need to get the cookie from the bot. So
Let's link it first.
yes. So now we are going to do the payload to visit our webhook.
Wait.
So he's going to go to the web. Okay. This is our webhook. Copy the URL and put it in. And the slide to stick. So before our URL, we need to put a fetch like this, and then we need to specify our URL in quotes like this. So at the end,
Then question mark.
yeah, question mark, and then plus document
Document.
document
You see inside the quotes?
outside. Okay, and then let's see if this works. We're gonna hack ourselves. Can you work? Yeah. Okay, so now you can see you can see we have two cookies now, and it's a bit messed up, but our first cookie is called ASDF with an empty value. Our second cookie is called ADDF, also with an empty value. So now let's get it from the bot. Submit. Okay, now go to webhook. And we have the flag here.
I don't know why you work on your
Okay. Okay, now we've done a lot of payloads on all these training challenges, but let's look at what a real CTF challenge is going to look like. Because after all, we are trying to, we are trying to learn CTF, right? So let's look at a real CTF challenge. I'm going to solve a CTF challenge on the spot now. Easy one, but it's not easy.
Just let me give me a moment. okay, if you guys want to practice more challenges, right, you can go to this website. It's called picoctf.org. Let me magnify. picoctf.org over here. You can go to this website and then you go to the practice tab. You can see there's a lot of challenges there for you to practice. Today we're doing web, so go to the web one. You can even filter by difficulty, so easy and web exploitation. Then there's some stuff here. Let's do something we've done. Okay, this one is not something we've done before, but it's something easier than what we've done before. So let's try this. Inspect HTML. Okay, our instance is over here. Okay, so description is, can you get the flag? Go to this website and see what you can discover. Inspect HTML. So the title is Inspect HTML. It means that probably we need to use the inspect element to get the flag. So if you go to here, okay, whatever. That's the inspect element. Let me okay. Element. Oh, that's all. Okay, this is too easy, bro. Too easy. Yeah, the flag was just inspect. Let's do something else. XSS, SQL injection is correct linking. Inspect. Keys. Okay. Keys. No. This, I remember the challenge was so bad. So guessy. The challenge is don't use client side. I don't know what the challenge is about. I solved it before, but I forgot already. Let's do it. Go. Enter valid credentials to proceed. Incorrect password. Okay. Based on the title of the challenge, it says don't use client side. So client side, we know there's HTML, CSS, JS. Most likely is something to do with them, right? Same thing, let's do an inspect element. And then we have some script text over here. Let me zoom in. Okay, there's a JavaScript function here called verify. And you can see, we can really see Pico. PicoCTF is the flag format, right? So you can see there's PicoCTF something. So most likely that's our flag. So in this case, all we need to do is, so after we inspect element, we can see our flag is jumbled up over here. We just need to piece the flag together. And that's all. There's still no XSS. I don't know where they are. XSS. Yeah, I'll let you guys know this. Quite easy. Where are they? Is it log on? Okay, this one looks promising. Log on. Okay, can you log in as Joe and find what they've been looking at? So now we want to log in as a user called Joe. Let's try Joe, some password. Oh, we logged in, but no flag. Let's do inspect element. Okay, it says that we have a login console, right? Maybe you can try some XSS first. SQLi first. So we put single quotes and see if anything happens. Oh, we still log in. No flag for me. No flag. Let's look at the cookies. Oh. Okay, we see some cookies here. Let me zoom in. So we have a bunch of cookies. I didn't set these, so it means that the website must have set these. I guess we just want to change admin to true. Let's try it. True. Unfortunately, this again is not SQL injection. So what we've done is we've changed the cookie to true and let's reload. That's all. Where are their SQL injection? Maybe it's medium. Is SQL injection medium? No. Okay. More SQLite. This is definitely an SQL injection. SQL injection challenge. Try to find the flag here again. Let's go, let's go. Please log in. You know it's SQL injection. Let's log in. Admin. Our basic password. Our basic bypass or 1 equals 1 dash. Okay, we're in. So now we've logged in as an admin. Then we have this weird table output over here, right? Table output sounds quite familiar, right? Union select. Anyone want to try union select? Okay, this one will be quite complex. So this union select, we need to first okay, let's verify that we can do union select first. So we just put a code. Yeah, just put a code. See if it errors out. Okay, I mean it didn't return anything. Let's try or 1 equals 1. See if we have any output. Okay, very good. So when I put a single code, right? I put a single code, it didn't error out. Remember just now I said if you want to test if there's SQL injection, we put a single code and then we see if the website errors out. In this case, it didn't error out. So there's probably some try catch at the end, at the back end that's catching our exception. And then if there's an exception, it just returns nothing. But if you saw earlier when I did or 1 equals 1, the same payload that we use for login bypass. This one returned a list of all the cities again. And obviously there's no city name single quote space or 1 equals 1 space dash dash space. So we know that something fishy is going on here, right? So let's do union select. Okay, so this is our, now this is the first step of union select. We want to find out how many columns we are selecting. Our table here has 3 columns, right? 3 columns means we have to be selecting at least 3 columns. So let's go ahead and put 3 nows. Now. That's all. No. Okay, our condition for error is that there is no output. So we have more than 3 columns. Let's do it again. So we have more than 3 columns. Let's try 4. Let's try 4. Union select now. Peace. Union select now. Actually, let's use 1 instead. 1. It's the same thing, just that sometimes now doesn't work. Union select 1. Maybe it has 5 columns. Maybe it has 6 columns. Oh my days! Actually, wow, this is ridiculous. 1. Maybe my payload is just wrong. I'm doing wrong. 1. 6 columns. Bro, what? 7. Okay, at this point, right, like it's getting quite ridiculous already. I don't think this is gonna work. So we have to try something else. So we know that we have SQL injection here, right? We're trying to find out how many columns there were, but it seems like maybe this specific dialect doesn't allow us to select values like this. What can we do? Let's see if we have a users table. No. Search office. Okay, we can probably make an educated guess. Maybe their office table is called officers. So select star from. I mean, this is just a wild guess. Let's see. Officers. I don't know this one. It's a bit guessy, man. This thing. So, I don't know. Let's see again. Give me one moment. Oh. Okay. My bad, guys. I have found my mistake. I made a grave mistake. When we were doing the payload, I didn't put a semicolon at the end of my payload. So let me zoom in. Sorry. Yes, you can see over here. So earlier, what I was doing it without a semicolon. I mentioned that sometimes, I didn't mention that, but sometimes you can omit the semicolon. Sometimes you cannot. It depends what is the adapter in the back end expecting. If it's expecting you to put a semicolon, then you have to put a semicolon. So in this case, I guess you have to. And we know because we got an output from this. We got output 111 from this. So there are exactly 3 columns that we are selecting. Next, we need to identify the database dialect that is running in the back end so that we can do the database introspection. So let's start with SQLite first. So select one, name, SQL from SQLite master, semicolon, and then yes, let's try. Okay, let's go down. We have 5 tables in here. Ignoring this SQL auto index users one, we have 4 tables. The hints table, more table, officers and users. Officers and users, we already know there's nothing here because actually there may be something in users, but let's see first. Oh wait, never mind. So we can see there's a table called more table, and then it has a column called flag. So, okay, just to recap, what I've done here, this is the payload. Union select one name SQL from master semicolon. And from this payload, we learn 2 things. We learn that the backend is using SQLite, and we learn that there's a table called more table with a column called flag. So now let's change SQLite to more underscore table. Change this to flag. And we should get our flag. Getting SQL injection like we should. Yippee! Okay. Honestly, I didn't know what I should do. I guess. Okay, I think that's enough demo for today. So, that's kind of like the methodology when you're approaching web challenges. Sometimes they don't give you source. I give you source because it's for learning purposes. If they don't give you source, it's a bit of trial and error that you need to do here. So you need to see whether there's a vulnerability in the first place. You need to see if find out certain things like what dialect is using in the back end and so on, right? All this is part of web. All this is why I actually stopped doing web. I used to be a web main like maybe 2 years back. Then honestly I felt like a lot of web challenges, especially in Singapore, like they set web challenges to be a bit more guessy. They don't give you the source, and they expect you to just like enumerate all these. It's more realistic. Like honestly, let's say like, I'm doing the padlet XSS. I don't have the padlet source code, right? But I just want to try various payloads and then see whether it works. It doesn't work anymore. So, but it's part and parcel of like web exploitation, So, you need to get used to it if you want to main web. I still do web from time to time if there are like good web challenges. So if you want, you can ask me about stuff. Yeah, I don't know this. Okay, just now someone in the tickets, right? They were asking, how do we identify if you have the source code? How do we know whether there's SQL injection or if there's XSS? So I'm just going to show you again real quick. So for XSS, you can see that for SQL injection is very easy to tell. The moment you have this thing where it's directly concatenating user input into a string, and then using that string as the SQL query, you know you definitely have SQL injection already. A counter example would be actually the XSS challenge is not vulnerable to SQL injection, but it has a database. So I'll show you what is an example of safe so-called safe usage of SQL SQL. In the XSS challenge, sorry. So it's also creating posts and then inserting into that, insert into post values, and you can see here it's not concatenating your string variables into the query. It's using this thing, these question marks here, and then passing the variables as additional parameters into your SQL adapter. So this is an example of prepared statements, some people call it prepared statements, some people call it parameterized statements. It means that you let the SQL adapter, you give the SQL adapter two values. The first value is the query that you want to execute with placeholder values here for the variables that you want the adapter to insert in. And then you let the adapter do the work. The adapter, whether the adapter is safe or not, it depends. There was another adapter that I wanted to show you that even with prepared expressions, it's still not safe. Whether it's safe or not, we don't know, but it's none of our business. It's not our business to care whether the adapter is safe or not. It's our business to care whether we use it safely, right? So as long as we use prepared statements, we can be quite certain that there is no SQL injection. As opposed to this one we are directly inserting the variable in. Okay, this is for SQL injection. So this method only works if you have the source code. If you don't have the source code, then you have to resort to blindly guessing and seeing whether there is SQL injection. Let's look at XSS. XSS is a bit harder to tell. So for my specific challenge, our input here, instead of putting let me give you the counter example. This is the safe way to use template thing in Python. Result direction. So this is a safe way to do templating in Python. We simply put double brackets, double curly braces, followed by the variable, right? But an unsafe way of doing it would be to do, ironically, to specify that this content is safe. So what this means is that you're telling the templating engine, I trust the content that's being passed in. Don't do any escaping. Don't do any. Just put my content in as is, and this means that an attacker will be able to pass in untrusted input, pass in a certain payload that allows us to get SSS. So it's very difficult to tell from the source code whether you can get SSS or not, because it depends on a lot of different factors. But the easiest way to tell is just to go ahead and try to put in some HTML text, HTML elements. So this one is 502, right? So the way we found out that there was SSS is we just went to the thing and then we put in like script text. Alert 1. And then when we submit this and then view our posts, we find out that it indeed executes alert 1. So this is how we know that there is XSS. Yeah, and it depends from vulnerability to vulnerability. So for SSTI, if you read the slides ahead, it's a similar method because there are a lot of templating engines, and it's very difficult for us to tell from the source code whether there is SSTI. But the best way to tell is to try to put in a working payload. If the payload returns something unexpected, or if the backend errors out, then we know that something fishy is going on, something weird is going on, and then we can proceed from there. Yeah, actually, this is a very good way to approach blind or like black box testing. We usually an application should not be erroring out. If an application errors out, right, even for this methodology I use it for home more often. If an application errors out, it means that our input was actually something that our application didn't expect. Unless of course you are like DDoSing my server, like just now my server went down, right? Apart from that, most of the time when we supply a certain input and then the server or the application errors out, right, it means that that input is doing something fishy in the application and doing something weird. And a lot of times when something weird is happening, something bad can happen also. Yeah. We'll look more at phone on day 4, and it's very fun. So you guys should do phone. Yeah. That's all. Okay. I will not be going through SSTI, and I said earlier. So I'll just do a brief run through. If you want to do more, or if you want to learn about SSTI, right, you can go to the 5003. I think that's the channel. 503. 503. The challenge at 503 is a classic Jinja 2 SSTI challenge. The slides here will teach you how to do SSTI, and then it will give you certain payloads that you can use to exploit this SSTI. So just a brief run through. So I'll skip all this. I'll just go straight to the payloads actually. So in the end, when you after you go through all the slides, you will learn how to construct these payloads, or at the very least how to use these payloads, and then these payloads will allow you to execute arbitrary commands. So arbitrary like Linux commands, bash commands, and from there you can compromise the server. You can cat certain files from the server, or you can like just shut down the server or something like that. And yeah, okay, that'll be all for SSTI, and that's the end of our web workshop today. Yay! Okay, if you want to do more stuff, or you want to learn more stuff, because today's one is very brief. A lot of the things I went through very briefly. I think you may need some time to digest at home also. If you want to learn more, right, you can go to this. Okay, so the first one is payloads, all the things. It's a collection of a lot of payloads. A collection of a lot of payloads that we can use for different kinds of web vulnerabilities. So, yeah. Later there will be a Google form that you guys need to do. It will be in the Discord announcements, training announcements. Yeah, training announcements. Then please fill in the form. Yeah. Thanks. Okay. Yeah, you can see there's a lot. All these folders are like different vulnerabilities, different web bounds, and I encourage you to, if you want to learn more about web, you can go into each one. Like let's say CNC direction. You go inside and then you look through the payloads. There's a bunch of payloads here. Then you look through the payloads and try to understand what these payloads are doing, so that when you encounter a CTF challenge in the future, there is where you can use these payloads, right? You know when to use these payloads. You know how to modify the payloads solve your specific challenge, because your payload may not, this payload here may not work for all challenges, but you know how to modify your payload to do it. Yeah. And honestly, it's quite a good resource. Another one, specifically for web, is okay. BlahajCTF is also very good. BlahajCTF has a lot of beginner to medium, and even some pretty hard challenges. I have a lot. I'm pretty sure some of these hard challenges I couldn't solve as well. Like I don't know, but yeah, some of them are pretty hard. But you can do the easy and medium ones. I think these are more doable. And yeah, for Pico, right, there are a lot of write-ups online. If you just search like this one, SSTI2, right, and then Pico SSTI2, you find a lot of write-ups online on how other people solve this challenge. I don't encourage you to read these write-ups straight away, because it will take away the learning process. Because once you manage to get the flag, you probably won't do the challenge again. So a better way is to try on your own first. Try for, usually when I was learning, usually I try for like maybe 1 or 2 days. If I cannot find, if I really don't know what I'm doing, then I'll go and do it in the write-up. I'll look through the first few steps. Then I'll see, oh, okay, this is what they want me to do. Then from there, I'll go and Google more about this. Let's say it's SSTI. I'll go and Google how to do SSTI or how to get RC from SSTI, and then try to develop my own payload first. If you are really lost and you've tried your best really and you really cannot solve it, right, then you can go ahead and read the write-up. It's still good for learning. It's just that process of trying is quite important. Trying and failing is very important. Yeah. Okay, and the last. Okay, there's one more resource, Podswigger Academy. This one, Podswigger. This one is more structured learning. So BlahajCTF is a bunch of challenges, past CTF challenges that a collection of past CTF challenges. For Podswigger Academy, right? If you go to Podswigger, I think dash. Okay, I'm not logged in, but if you go in, right, they have a list of like quite exhaustive learning resources and challenges that you can try. They will guide you so it's a very guided process. They will teach you the basic stuff first, and then they'll introduce some filters or some blacklists, and then you need to bypass the blacklist. Quite good for learning web. And if you have any other questions, if you want to learn more, you can message me on Discord. I'm Samuzora, and Jia Jie, he's not here today, but he's better at web than me actually. He's our main webber for SlideSmart. You can ask either of us on Discord. Just feel free to open a ticket, or if you want, you can even PM us. Yeah, and yeah, okay. That's all. Yippee! The end. I hope today wasn't too hard for you guys. If you find it really hard, right, it's okay, because it's a lot of content to fit within like half a day. Do go to the training announcements. Fill in the Google Forms. And then anything else?
Hi, please show proof that you have done the form before leaving. So I'll be sitting there. And when you all leave, just show like the completion of the form, the page. Yeah, thank you.
Okay, thank you so much, guys. End stream. Oh, okay. Is Ian Ong here? Ian Ong. Yeah. Something to do with your home. Yeah.
Could you